On behalf of the court organizing committee, good morning and welcome to the online 6th International Symposium on Green Technology for Value Chain 2022. This event is profoundly presented to you by the Research Center for Environmental and Clean Technology, the National Research and Innovation Agency, Republic of Indonesia. My name is Nur Akmalia Hidayati. I will be served for MC for today. Let me begin the opening ceremony. To the Honorable Dr. Iman Hidayat, Chairman of Research Organization for Life Sciences and Environment, the National Research and Innovation Agency, Republic of Indonesia. To Our Excellency, Head of Research Center for Environmental and Clean Technologies, Dr. Sasa Sofyan Munawar. To the Honorable Keynote Speakers, Professor Kurunta Chalam Kanan from the Department of Environmental Medicine, New York University, Grossman School of Medicine, New York. Associate Professor Muhammad Aziz from the University of Tokyo, Japan. Dr. Kwan Young Kim from the Green Technology Partnership, South Korea. To our distinguished guest presenters, ladies and gentlemen. As our first agenda today, I would like to invite His Excellency, the Head of Research Center for Environmental and Green Technology, the National Research and Innovation Agency, Republic of Indonesia. Please welcome Dr. Sasa Sofyan Munawar. Dr. Sasa, the floor is yours.
Bismillahirrahmanirrahim. Honorable Dr. Iman Hidayat, Head of Research Organization for Life Science and Environment BRIN, keynote speakers, presenters, and all participants join us offline and online. Assalamualaikum warahmatullahi wabarakatuh. Good morning. It's my great pleasure to welcome you to this virtual conference of 6th International Symposium on Green Technology for Value Chains 2022. The GreenVC is an annual international symposium since 2016 that consistently gather expert, practitioners, and academic to share knowledge, exchange experience, and information toward meaningful discussion on the latest innovation and technology in environmental issues. This year, we invited the environmental and clean technology community to join and submit papers under the following themes: recent innovation in sustainable environment facing 5.0 society. A total of 119 presenters from Indonesia and abroad will present their papers, which are divided into 8 topics. There are 1. Waste treatment and valorization. 2. Clean water and drinking water treatment. 3. Environmental monitoring and assessment. 4. Climate change mitigation. 5. Environmental remediation and reclamation. 6. Environmental nanotechnology. 7. Green material and process. And 8. Clean technology. In addition, keynote speaker from Japan, Korea, Zambia, and the USA will present 5 interesting topics that are on the biomonitoring of human exposed to environmental chemical in the context of exposure, waste to energy, green technology, microplastic issues, and microalgae research and development. In this opportunity, I would like to express my deep gratitude to the organizing committee for their dedication and hard work in organizing this event. Also, many thanks to all of the speakers, presenters, and participants who joined this conference. We hope this symposium will be an excellent platform in increased green and clean technology innovation for sustainable resource in the future. Hereafter, please allow the Head of Research Organization for Life Science and Environmental BRIN to officially open this GreenVC. Thank you very much for your kind attention. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for your welcoming speech, Dr. Sasa. We are now coming to the next agenda, which is the opening remark by the chairman of Research Organization for Life Sciences and Environment, Dr. Iman Hidayat. Please welcome Dr. Iman. Dr. Iman, the time is yours.
Thank you, moderator. Honorable Director of Research Center for Environment and Clean Technology BRIN, Dr. Sasa Sofia Munawar, keynote speakers, all audience participants online and offline. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. It is my great pleasure to welcome all of you to the 6th International Symposium on Green Technology for Value Chains 2022. This year event is the second year we are holding this symposium virtually, except for the symposium organizing committee, of course, who have worked very hard in preparing this symposium. And therefore, I greatly appreciate it, and many thanks to all of you for your hard work and for taking your precious time in preparing the symposium and for successful of this symposium. I also greatly appreciate for the keynote speaker who will share the knowledge and will discuss with all the audience in this event. And also many thanks to all participants of this symposium. Ladies and gentlemen, in this opportunity, I would like all of us to reflect again. Why do we need green technology? Or do we really need green technology? That's a common question now. If we care about our self-health condition, if we care about the place where we live, or if we care about the carrying capacity of the environment where our children or grandchildren or future generation live, and then the answer is yes, we need to apply green technology now. Ladies and gentlemen, every day now, especially in developing country, in the big city, we breathe toxic air, toxic gases from emission from transportation, motorcycle, cars, and so on. Therefore, we need green transportation. And these vehicles cannot move without energy. 100 years already, we are enjoying using fossil fuels energy from coal, from oil, and so on. It causes the global warming. It causes gas emission, greenhouse effect on our environmental. The earth is getting hot. Therefore, we need to decrease the pollution from using not green energy, from using fossil fuel energy. We need greener energy. For example, thermal energy or solar cell energy or fuel cell energy or energy storage and so on. Related technology that more green to the environment. Another important issue relating to the environment is water. In the big city, to get the clean water now is much more, in the processing it's much more difficult. Therefore, the cost to get the clean water in the big city is increasing every year. We can imagine in a small island, in dry area, small island, they used to have saline water. In dry island, very difficult to get the clean water. They need the technology to processing the water so they can get clean water or drinking water. And we are all here gathered together to share what we are finding, what we have, the technology to processing the water, and then we can implement later for the people in dry area or in small island. With the increasing of the population around the world, the use of water will increase, definitely. But the number of water is still the same. So we need the technology. And maybe in the next several years, water will be the main factor of global issue. Everywhere will be concerned about the water. In Indonesia, 20 years ago, I think the people in Indonesia never think that we have to buy a bottle of water 5,000 rupiah. No, but now to get one bottle of water, we need to pay 3,000, 5,000 rupiah. It's getting more expensive to have drinking water. Many environmental issues, including soil pollution from mining activities, air pollution from industries or from transportation, plastic materials everywhere. We need the material. These environmental issues we need to address. And the front line are scientists. We are all here. It's the front line to answer, to address these environmental issues. Therefore, as I mentioned before, we need the green technology now, not tomorrow, because maybe tomorrow will be late. So in this opportunity, I would like to encourage everybody here in the symposium to have a discussion with the keynote speaker to share their knowledge, their technology, their invention with other audience. We discuss here together in the symposium to get many solutions for the many environmental issues. Because of what? Because environmental issues cannot be answered by a single organization, cannot be answered by a single discipline, science. It should be collaboration, the answer. So we need to collaborate to answer all environmental issues. Ladies and gentlemen, finally, please make the GreenVC 2022 as a place or as a platform for all of you to enhance, to communicate, to enhance networking, to enhance collaboration, together to answer all environmental issues. Because the people all around the world need the green technology now for a better of our living environmental. Therefore, finally, I would like to encourage again that from this symposium, I do hope that we will get something interesting, especially new technology or new invention from all participant keynote speaker for green earth or for sustainable earth, because we are living in the earth. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for your opening remark, Dr. Iman. Before we are going to the next session, I would like to invite all guests and participants to have the morning photo session. Please turn on your video, and if necessary, please also open your mask. And the photo session will be guided by the organizing committee, so please give us a cue. Okay, I will start from the slide 1. So everyone in the slide 1, please open your video. 1, 2, 3. Smile, everyone. Okay, for the next slide. 1, 2, 3. Okay. And for the third slide. 1, 2, 3. Okay. For the fourth slide. 1, 2, 3. And then for the fifth slide. 1, 2, 3. Okay, thank you everyone for participating in the photo session. Now, ladies and gentlemen, before we proceed to the first keynote session, we will have a break for 5 minutes, so please enjoy the video.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies. Ecosystem, building an economy foundation.
Sekarang yang terjadi, terobosan itu menjadi mungkin oleh yang namanya, saya ulang, oleh yang namanya ilmu pengetahuan, oleh yang namanya teknologi, oleh yang namanya inovasi.
In 2020, Indonesia entered a new national development era. On this term, President Joko Widodo administration turned its focus on developing Indonesia's human capital and mastery of science and technology through Indonesia's national research priorities. The quality of a country's research and innovation is a national asset. As a key step, the government issued Law No. 11/2019 on the National System of Science and Technology, or the Sisnas Iptek Law. By issuing the law, the government of Indonesia was signaling more attention to and commitment for the growth of the research and innovation during the next phase of Indonesia's development. 9 research fields are listed as the focus fields of Indonesia's 2017-2045 National Research Master Plan. Food, energy, health, transportation. Engineered products. Defense and security. Maritime. Social, humanities, and other research fields. These are expected to be able to produce innovative products. With the Presidential Regulation Number 74 of 2019 on the National Research and Innovation Agency. The President has tasked BRIN to ensure that research and development activities in the country could attract more investments to its science and technology sectors, integrating research and innovation resources, creating and open a collaborative global standard research ecosystem, and creating the foundation of a strong and sustained research and innovation-based economy are three directions of BRIN. The contribution of research and innovation to produce a variety of solutions can resolve the challenges faced by the government, industry, and society.
Welcome back, ladies and gentlemen. Good morning to everyone who join us in the Zoom and YouTube platform. For our schedule today, we will have 3 keynote speakers and 3 oral sessions. Each session will be guided by the chair as the moderator. Before we begin our first talk, again, we profoundly request to all participants to mute your microphone during this session, and we highly appreciate if you're willing to turn on your video during this event. If you have any question, please write down your question in English in the chat box during the presentation, because we will have question and answers right after each keynote session, or simply click raise hand button and the chairperson will give you the permission to ask question. Please write your name and for whom the question is. To begin with, I would like to invite Dr. Agus Sudaryanto, who will guide us as chair for the first keynote session. In the session, we will have Professor Kurunta Chalamkanan from the Department of Environmental Medicine, New York University, Grossman School of Medicine. Dr. Agus, are you already there?
Okay.
Okay. Without waiting any further, the time is yours. Thank you.
Okay, thank you, MC. The honorable keynote speakers, participants, ladies and gentlemen, good morning. So my name is Agus Sudaryanto from Research Center for Environmental and Clean Technology BRIN. And I will be a chair for the first keynote speaker by Professor Kurunta Chalamkanan. And I think we have Professor Kanan here already. Good evening, Professor Kanan. How are you?
Very good, Agus. How are you doing?
Oh, fine. Thank you.
Thank you for having me.
Okay. So before the presentation started, I would like to remind again, both for the speaker and audience. So for the speaker, Professor Kanan, you will have 30 minutes for the presentations and 15 minutes for discussions. And for the audience, I request to all of you to mute your microphone during the session. And you have any question, please write down your question in English in the chat box during the presentation, because we will have a discussion right after the presentation. Or later in Q&A session, you you could simply click raise hand button for the question. And now we will soon begin with the presentation, and I would like to invite Professor Kurunta Calamkanan from Department of Environmental Medicine, New York University, Gersman School of Medicine, New York. So, in this presentation, he will give a talk about monitoring of human exposure to environmental chemicals and the context of exposure. But before start, I would like to introduce to the audience the biodata of the speaker. So, Dr. Kurunta Calamkanan is a professor in the Department of Pediatrics and Department of Environmental Medicine at New York University School of Medicine. He has published over 800 research articles and peer-reviewed journals. Dr. Kanan is a highly cited researcher in environmental sciences with H index of 140 for Google Scholar. He is known for his work on the discovery of perfluorochemicals in the global environment. Currently, his research is focused on biomonitoring of human exposure to organic pollutants. He was on the editorial board of several journals and editor-in-chief of several journals. Dr. Kanan is well known internationally for his work on contaminants in the environment. So, okay, Professor Kanan, time is yours.
Thank you, Agus. Good morning, everyone. Thank you for inviting me and for the organizers to put together this very important and wonderful symposium. Very glad to be a part of this meeting. And let me put on my slides. Okay. Can you see my slides, Agus?
Yes.
Okay, good. So for over 20 years, my research has been focused on the assessment of human exposure to environmental chemicals. Of course, I graduated with the PhD almost 30 years ago. And, for a long period of time, my research was focused on environmental distribution and fate of chemicals. But in the past 20 years, my research is focused more on human exposure to environmental chemicals and how those exposures can affect health. Now you can see I am in a medical school. I'm not a medical doctor, but there is a lot of interest among medical doctors about environmental chemical exposures. That's why I'm in the School of Medicine. So I will talk a little bit about what I do for my research. Oops. So in my title, I introduced the concept exposome. Let us start with what is exposome. Okay. This is a new term. In exposure science area, exposome is used in the past 15 years. So in 2005, a cancer epidemiologist coined this term, exposome. What does it mean? Exposome means totality of human exposure to everything, not only chemicals, but also exposure to social factors, dietary factors. There are so many different exposures that we encounter every day. And from conception, when you were a fetus, you were exposed to a lot of chemicals. When you were a child, you were exposed to many chemicals. When you were adolescent, you were exposed to many chemicals. And in adult stage, you are exposed to many chemicals. So exposome basically studies exposure to everything from the fetal stages, from conception. Okay. Why is this exposome? Many of you might know genomics, proteomics, metabolomics, many omics technology, right? Particularly genomics. Human genome was sequenced 20 years ago. In 2003, human genome sequence was completed. At that time, we all thought, oh, once the human genome is sequenced, we can find cure for all the diseases. If you have some health problem, if you have illness, at that time, in 2003, we thought that if we know genome, we can find the cure. What happened? soon after the human genome was sequenced, it was realized that genetics or genome accounts for only a small percentage of diseases. Then what else is accounting for major portion of the diseases? It's the environment. Many of you know environment plays a major role in your health. It's a major factor in your health, right? So exposome complements genome. I don't say genome is not important. Genes are important, obviously, but it is the environment that's a major contributor to many diseases. And of course, environment and gene interaction is also important. So that's what the exposome is. Like genome, you have exposome. And exposomics is the study of exposome. And I will be talking a lot about biomonitoring of exposome. Biomonitoring is a tool, one of the tools used in exposomics research. Okay, so I want to talk a little bit about exposome and how it is linked to the health, right? So exposome is the study of exposures, many things, not only chemicals, but also diet and many other factors. And when you talk about exposure can come from your external environment, right? External environment means what? So it can be specific external environment, specific to you, or it can be a very general external environment, general to many different things, right? When you say specific, it can be from your diet, it can be from your water, it can be from your air, it can be from your personal care product that you are using every day. The general environmental factor can be from where you live. It's very general, right? It's not that you can control, because you have to live in, say, for example, Jakarta, because your job is in Jakarta, right? So you cannot control, because obviously your job is there. You have to live in a city and urban environment. And of course, many other factors, social factors, sometimes it's not under your control. All those can have an impact on your health, right? That's what eventually you can see on the right-hand side. It's all about your health, the environment. And then there is something in between, something between external environment and your health is your internal environment. So internal environment is how you process your chemical exposure. That is related to your genes, that is related to your proteins, that is related to your metabolism, and many other factors, right? Everyone has a little bit of difference in their internal environment. That's why sometimes you can see people smoke, say 40 years, but that person may not have cancer. But you know, many people smoke, maybe in 20 years they have cancer. Why is the difference? It is because of the internal environment. So the external environment and the internal environment of a person can contribute to the ultimate health outcome. Okay, so exposome is the study of all these external environments, internal environments, and then ultimate manifestation of all these exposures. So why the exposome has become an important topic in the last 15 years? 25 years ago, we didn't know about exposome. We were assessing exposures, but not based on the concept of exposome. Why? Is because in the past 15 years, many of you know, there is a breakthrough in lots of scientific disciplines. In biology, right? You can see here, you can do transcriptomics, proteomics, genomics, metabolomics, epigenomics. All these technologies have developed in the past 15 years, right? Of course, 20 years ago, this was not much known. Even if we can do it, was very expensive. But now we can do it easily, right? And then the big data analysis, bioinformatics, big breakthrough in the last 15 years. 25, 30 years ago, the computers were not very fast. They cannot accommodate a lot of memory, but now all supercomputers and also the methodology, the statistics, that big data analysis is all possible. And then you also have the technologies. You collect a lot of data, with all the AI, artificial intelligence, a lot of information is collected. Now you have the data available. When you go to hospitals, you give a lot of information. and the doctors collect all the information on the computer. And if a lot of people go, thousands of them go every day, data for thousands of people are stored in that computer. And then later you can analyze the data to get some information on why people from certain regions have certain types of cancer elevated, right? So now all that information is available, and that's why exposome has become a very important topic. And then I'm going to talk about biomonitoring. That's one of the tools to study exposome. It's not everything, one of the tools. Why? It's because of the improvements in analytical methodology, the GCMS, LCMS, Orbitrap mass spec, very highly sensitive analytical instrumentation. You give one drop of blood, we can measure thousands of chemicals with one drop of blood with high resolution mass spectrometry. And this was not available 25 years ago. Now it is available. So now is a very good time to study how the environment can affect your health, right? Because of all these technologies available. So I said something about biomonitoring. What's biomonitoring? Biomonitoring is the measurement of people's exposure to toxic chemicals by measuring those chemicals in blood, urine, hair, saliva, nails. You can use all those human specimens to assess chemical exposures. In the past, I did my studies almost 32 years ago, exposure assessment. At that time, it was different. It was not based on analysis of urine or blood. It was based on analysis of food, analysis of indoor air, analysis of dust, analysis of personal care products, and so on. But now, you take urine sample from any person, we can measure thousands of chemicals. We are all exposed to hundreds, if not thousands of toxic chemicals every day. Very small quantities, picogram, nanogram quantities, doesn't kill you immediately, but you are exposed to thousands of them, and then the mixture effect, what will happen if you are exposed to those thousands of chemicals every day over a period of your life. That's what the biomonitoring is about, measuring them in blood or serum or other human specimens. Biomonitoring has become very important public health program in many countries. USA, Canada, Germany, France, Japan, Korea. Many countries have national biomonitoring programs because the government knows how important to assess people's exposure to environmental chemicals and then link that exposure to health. So, because there are many benefits here. It can tell you what kind of chemicals you are exposed, what are the levels of exposure, and the changes in exposure over time. If you have a biomonitoring program, every year you measure chemicals in population, and then you can look at the trends. If the chemical levels are increasing, then that's a problem. Government can immediately take action to ban the chemical or to regulate the chemical. If the levels are decreasing because of some regulation, it's a good information for the government. And then you can also tell why some people are exposed more than others, right? We can find out the reason for exposure in some populations, and also look at the demographic factors affecting exposure. Some occupation, people working in some jobs may be exposed to high levels of some chemicals. So those jobs may lead to some health problems if people work in certain jobs. So those kinds of information can be made possible in these kinds of programs. But biomonitoring requires collaboration among many different scientists. I am a chemist, analytical chemist, environmental chemist, but I work with toxicologists. I work with epidemiologists. I work with medical doctors. That's why I'm in medical school, and also public health scientists. So you need to have a very open mind. If you want to advance the science, you have to work with lots of different collaborators. Sometimes it's not easy because, sometimes epidemiologists think what they do is more important than chemists. Toxicologists may think, they are more important. Everybody is important, but we have to work together to advance the science, at least as we move forward. So I want to give you some example, quick example, how we did biomonitoring. For example, I want to give one class of chemicals, phthalates, right? So we measure chemicals in urine or blood or brain or some tissues. And then, as I told you in the past, we measure chemical exposures based on measuring chemicals in food, water, or air, personal care products. And depending on how much you ingest, you can calculate the exposure dose. So that's the external exposure dose. And based on biomonitoring, you measure internal dose, what is in your body, right? Because I have been doing both for almost 32 years now. I in my lab, we try to do both to see if external dose we measure is equal to internal dose. If it is equal, then it is good news. We accounted for all the sources of exposure. But if internal dose is higher than external dose, which means we missed some of the external sources, then we go after those sources, right? So in science, exposure science, that's very important. So I want to give an example for one class of chemicals. We have done this for many different classes of chemicals. So phthalates, many of you know, these are plasticizers used in many plastic products. And we use a lot of plastics in our lives. So we are all exposed to phthalates in enough concentrations every day. Phthalates are plasticizers used to make plastics flexible, durable, and cheap. They are very high production volume chemicals. And some phthalates are regulated in the United States in child care products because of the toxicity. Phthalates are known reproductive toxicants. And there are many different types of phthalates. Some like monoethyl phthalate, dimethyl phthalate, diethyl phthalate, dibutyl phthalates. They are low molecular weight phthalates. They are mostly used in cosmetics. So if you use fragrances, deodorants, antiperspirants, nail polish, lipstick, they have low molecular weight phthalates. And high molecular weight phthalates are mostly used in vinyl products. For example, vinyl flooring has diethyl phthalate and benzyl butyl phthalate. So there are many different types of phthalates. They are used widely in automotives like cars, many automobiles, building and construction materials. You have a lot of plastics, right? Flooring, like here, the floor is made up of vinyl. Cosmetics like nail polish, many medical care products in hospitals, and also in baby toys, plastics, right? So again, babies can be exposed to high levels of phthalates. So when you're exposed to phthalates, our body metabolizes phthalates. We are all exposed. Everybody is exposed to phthalates. Body metabolized. So the diethyl phthalate become monoethyl phthalate, which gets glucuronidated and excreted in urine. So if you take urine samples, you can measure all different types of phthalates, mostly as monoesters, because we are exposed to diesters, but body breaks down to monoesters and then excreted in urine, right? So in urine, we measure monoester, but you can calculate back as diester as in terms of exposure dose. So about 15 years ago, we were interested in looking at phthalate exposures in many Asian countries, because my work is mostly focused on multinational studies. We have collaborators from many different countries. So at that time, about 15 years ago, we had samples from Kuwait, India, Malaysia, Vietnam, China, Korea, and Japan. At that time, there was no information about phthalate exposure in those countries. So what did we find? Yes, there was exposure. The concentrations in urine ranged from 2.6 nanogram per milliliter to 19,300 nanogram per milliliter. So you can see some people are very highly exposed, 19,000 nanogram per milliliter. So 19 microgram per milliliter, which is 19 ppm. Some people are very high ppm levels in urine, which means they are very highly exposed to these plastic chemicals. So looking at these different countries, you can see China, India, Japan, Korea, the median concentrations are between 100 to 300 nanogram per milliliter, but come to Kuwait, median concentration is 1,000 nanogram per milliliter. So population in Kuwait is very highly exposed. At the time, my Kuwaiti collaborator didn't know what's happening. He didn't know what these chemicals are. So now they have a program, nationwide program, to look at the sources of exposure. So sometimes when I say 5 ppm, 10 ppm, 5 nanogram per milliliter, is it high or low, right? That's the question many people will ask. What we have to do, we have to convert the concentration to an exposure dose. That can be used in risk assessment, right? So how can you calculate the exposure dose, that is daily intake, based on the concentration? Is if you know the volume of urine excreted, everybody excretes approximately 2 liters of urine every day, because we drink 2 liters of water. So concentration, if it is concentration is 1 microgram per liter, if you are excreting 2 liters of urine, then you are excreting 2 micrograms, right, every day. And then the M1, M2 is molecular weight difference, because we measure metabolites in urine, and then we are calculating the exposure dose of the parent compound. So you have to use this molecular weight difference. And F is the fraction of the chemical excreted in urine. For some chemicals, 100% is excreted in urine. Some chemicals, only 10% is excreted in urine. So you have to use that factor to calculate the exposure dose. The exposure dose is mostly microgram per day, right? Or milligram per day. How many milligram you are ingesting every day. I'm going to stop talking about all the other countries, just focus on one country, USA. So in the USA, we found out that the median exposure dose is 500 to 600 microgram every day. So an average American is ingesting 500 to 600 microgram of phthalates every day, 0.5 milligram every day. So it's almost like eating 0.5 milligram of plastic, right? So everybody is eating in America 0.5 milligram of plastic. You can say that. So when I give these kinds of talks, the question immediately is, so again, this value can be compared with the reference dose, because if we calculate the exposure dose, the government has the tolerance limit. So you can see DEP 800 microgram per day is the dose, DBP. So different phthalates have different exposure doses. So from there, you can calculate if you are exposed more than the tolerance limit, if you are at risk from exposure, right? So then the next question is, where do I get my exposure? So we analyzed many personal care products. So for adult female, because they use nail polish, lipstick, deodorants, all kinds of things, exposure comes from, of course, nail polish, you can see up to several thousand microgram per gram, ppm, right? So if you use them, you can get 22 microgram of phthalate exposure every day. From indoor air, because inside the home, you have lots of plastics. So the air has phthalates, several thousand nanogram per cubic meter. And also the dust has phthalates. We are ingesting dust. So the exposure dose is 16 microgram per day. And food, many foodstuffs are packaged in plastics. And we calculated the exposure dose, 60 microgram per day. So in the previous slide, I told you, based on urine, it is 550 microgram per day. Personal care products, only 22. Indoor air and dust, only 16. Food, only 60. So that comes to 98 microgram per day. But when you measure urine, it is 550 microgram per day, right? So food, air, dust, personal care product, only 1/5 of the total exposure. What are the other sources? We don't know. So if we use a traditional approach of exposure assessment, we will be missing a lot of exposure doses. That's why biomonitoring is very interesting and important, because it can account for exposure from many different sources that we don't know sometimes. So we did a study looking at what are the other sources of phthalates. Many medical devices, many pills, pharmaceuticals contain phthalates. You will be surprised. Of course, I told you toys, sometimes even clothing. There are many different sources of phthalates that we go after and we measure them. So biomonitoring is also useful in making lots of discoveries. For example, many of you know bisphenol A. It's an endocrine disrupting chemical. About 20 years ago, again 15 years ago, we did a study looking at BPA exposure in populations. At that time, we know BPA was replaced with many other bisphenols, BPS, BPF, BPB, because industries tried to change these formulations, make new chemicals. But are these new chemicals any less toxic? No. We know that, and there are many studies with bisphenol S, bisphenol F. So in 2015, we were the first to report BPS in urine samples. 2000, like almost 15 years ago, we did these studies. So I highlighted Japan here because, as you can see in Japan, samples collected in 2001, less BPA compared to many other countries, compared to India, compared to US, Korea. Japan had lower concentration. But if you look at the BPS, Japan had much higher than other countries because Japan replaced BPA with BPS. So in urine, you can see high levels of BPS. And that is also reflected in receipt papers, thermal receipt papers. When you go to grocery store, when you touch the receipt paper, the thermal receipt paper, it has BPA or BPS now. So you can see in Japan, receipt samples collected at the time, it's in milligram per gram. It's not, it's spots per 1,000, not spots per million, okay? Several milligrams in 1 gram of paper. You can see that BPA not much in Japan, but BPS is very high in Japan. So obviously, Japanese population exposed to receipt papers, and that is reflected in urine, right? So in exposure science, we do all these kinds of things. And as I told you, we have done many different studies looking at parabens, which are used as antimicrobials in cosmetics and pharmaceuticals. These are all the studies we did for the first time, almost 15 years ago. Nobody did these kinds of, first studies. Now there are lots of papers after that in many countries showing exposures. And all these chemicals are toxic chemicals. Parabens are implicated in breast cancer, right? And they are used in cosmetics. And ladies use a lot of cosmetics. And, now you have a breast cancer causing chemical or chemical that is known to cause breast cancer used in many cosmetics, even today. So we did a study looking at many different countries. You can see Korea had the highest exposure, China next. And of course, these exposures are very ubiquitous. Many countries, you can see people getting exposed. But these data were not available for many countries, especially developing countries. We don't have data. That's why sometimes I feel that it is very important for developing countries to start these kinds of programs. It's very important to protect not only us, but also our future generation, right? Again, another class of chemical looking at, again, exposures. This is a chlorophenol used as a pesticide. And also another class of pesticides, chlorpyrifos. So some countries like Vietnam, they use lots of pesticides. They have high pesticide exposure. So we do. I think somebody has to mute. Okay, so you can see, we do a lot of multinational studies looking at all different types of hundreds of thousands of chemicals, we have measured in urine samples. So in the end, we want to bring them all together to see how these exposures are associated with health, right? So we work with a lot of bioinformatics specialists. We produce a lot of data. So this is one study looking at couples, okay, both male and female. They wanted to have babies. So we collected urine from both couples from the time they wanted to have babies and looking at chemical exposures. And then what we found, of course, we measured lots of different chemicals. You can see many organochlorine pesticides, PCBs, dioxins, phthalates, phytoestrogens, phenols, antimicrobials, medications, many different things, melatonin, many things. And then we tried to correlate between males and females from the same home because they live in the same home. They wanted to have babies, but they are exposed to chemicals. So we were looking at if the couples are exposed to high levels of some chemicals, does it take long time for those couples to have babies, right? That's one of the endpoints used in epidemiology.
Professor
In this
Kanan,
particular
you
study,
have
what we found
1
was
minute
that,
more.
pardon?
You have 1 minute more, Professor Kanan.
Oh, okay, sure. So I will try to go fast. Maybe I need 3 more minutes. I will finish it. So what we found in this study was, although samples were taken from the same home, there was no correlation between these chemicals in males and females. It's because they go outside in the office, in the environment, they are exposed to different chemicals. So although they live in the same home, the exposures comes from different sources. So quickly, with the urine samples, you can do many different things. You can also measure health effect biomarkers, oxidative stress biomarkers, DNA damage from your urine samples. We have done some studies, again, looking at DNA damage markers in urine samples. So we can assess chemical exposure and then the DNA damage, protein damage, fatty acid damage in the same individual, right? So we have done that. So now bringing all together, what we are trying to do is to link exposure to health outcomes. So that is called adverse outcome pathway in diseases. So if you are exposed to, say, for example, phthalate, I told you phthalates are reproductive toxicants. What we found was if males are exposed to high levels of phthalates, the couple cannot have babies for a long time. Then we looked at the semen quality and phthalate exposure. So high phthalate exposure, semen quality becomes very bad. Then we also found that the oxidative stress is much higher in that population. So you can make a link from exposure to adverse reproductive health, right? In between, there are many different biological markers we can discover to make the connection. So that's how we conduct our biomonitoring, exposome, and exposure assessment, linking to human health, right? This is my summary slide. So I want to say that environmental chemical exposure is an important contributor to many diseases. That is the key concept in exposome and biomonitoring. Biomonitoring permits lots of discoveries. When you inject urine samples, you find lots of chemicals. You can make lots of discoveries. So for PhD students, very good topic for research. Okay. And biomonitoring offers the best way to quantify your chemical exposure. And you can also link exposure biomarkers with effect biomarkers like DNA damage marker, protein damage marker. In urine samples, you can do all those things to make exposure, effect, and disease linkage. That is the adverse outcome pathway. It's a kind of a new field. I told you only 15 years we have been doing this, but there are lots of interesting opportunities in the future for young people, and also it's important for many government agencies. So with that, I would like to stop and acknowledge, the funding agencies, mostly government agencies fund this kind of research. It's a very interesting research and important for our people and our future generation to do this kind of work. Thank you very much for your attention.
Thank you very much, Professor Kanan, for your very interesting presentations on biomonitoring of human exposure to environmental chemicals in the context of exposome. We have a very nice presentation that in the context of exposome, so we expose to everything to from early stage of life that complementing the genome. So I think it's very nice talk, and hope we have we'll have a good discussion for the Q&A session. And I think here we already several audience to ask. First, I think we call you Dr. Chandra, and then after that, Mr. Panji. So please, I think, Dr. Chandra, please.
Yeah, thank you very much, Dr. Agus. It is a very nice presentation, Professor Kanan, about the exposome. I would like to ask you, I was wondering, according to your data, in Kuwait, there was so high number of phthalate concentration. So, do you know maybe what do they do for decreasing it? Yeah.
Yeah.
And
so
the second,
yeah, sure,
is,
go ahead.
sorry, is there any safe compound that can replace the phthalate in this as a plasticizer? Do you think maybe? Thank you.
Very, very good question. So yeah, that, you know, those are the things that are very important. Sometimes environmental chemist, analytical chemist, exposure scientist, environmental health scientists like us try to say that, yeah, there is high exposure. We just don't want to make alarm, but it's also important to know what people can do to reduce the exposure. That's very important, right? So in Kuwait, I told you, we did this study almost 15 years ago. At that time, nothing was known. I collaborate with my friends in Kuwait. They are all food chemists. They were more interested in contaminants in food. Then this urine biomonitoring was something new for them. My idea was to introduce this field to my collaborators in developing countries, because I have a passion for working with scientists in developing countries, because it's important. You know, many developed countries, they invest money to develop these kinds of programs to help the public, to protect the public from all these toxic chemicals. So my collaborator in Kuwait, immediate question was, why we have so high exposure? But we know in Kuwait, of course, it's one of the lifestyle cultural practices that they use a lot of fragrances, right? Probably. So the exposure mostly comes from the use of fragrances. And of course, there are many other sources. So immediately after this study we published, they started writing research proposal to the Kuwaiti government. So there is a noon meal scheme program, phthalate in drinking water, phthalate in noon meal, because lunchtime they give a meal to kids and they use lots of plastic containers. There are many such phthalate projects started in Kuwait after our study. And, you know, they are now trying to understand not only the exposure sources, but to me, the major source is from using fragrances, okay? And they're also trying to understand what are the health implications. I told you phthalates are reproductive toxicants. Sometimes they are also reported as cardiovascular toxicants. So in Kuwait, they have lots of health problems, reproductive health problems, cardiovascular problems. So the epidemiologists are doing population level study, linking exposure to health outcomes. So that is happening. So your next question, what are the safe compounds, safe alternatives? Very good question. But, you know, I'm working in this field for more than 32 years. Industries always, oh yeah, we say that, diethyl ethyl phthalate is bad. And immediately government go after the industry, because it's billion, they make billions of dollars from making these chemicals. Government say, oh man, this chemical is bad, go to industry. What are you doing? This is bad for our people. You have to stop. So then industry make, okay, they change the chemistry a little bit. Diethyl phthalate will become diisononyl phthalate. It's the same phthalate, change the chemistry a little bit. And in the market, they say diethyl ethyl phthalate free, like BPA free. You go to market, you will say BPA free, but it has BPS. BPS is more toxic than BPA. What will you do as a consumer, right? That is the problem as a consumer we are all facing. And it is the job of the scientists like us to raise the awareness. I don't want to alarm people, but my job is to impart knowledge, right? We don't want to keep our people fools. We want them to be enlightened. We want them to be aware, and of course, do good science, good research, and find the best alternative. That's how I approach, science in this field. So safe compounds, there is not really, but industries have made alternative phthalates, but the alternative phthalates are also phthalates, but different chemical names. Diethyl ethyl will become diisononyl, or di-N-octyl phthalate, and different kinds of phthalates.
Okay, thank you, Professor Kanan, for the answer. Very nice.
Okay.
Thank you.
Okay, and then we will move for the second question, and then the third is in the chat box. So please, the second question goes to Mr. Panji.
All right, thank you very much for the opportunity. Hi, Professor Kanan. That was a great presentation. Thank you for the enlightenment on the exposome studies. I see that you have been focusing on chemical exposure, and earlier in your presentation, you mentioned that the environmental exposure could also be biological, right? And
Right.
one thing that I've always wanted to explore more is the role of the microbiome, and I feel like this is very important, as different diets that we take would contain different microbiomes, and it would lead to alteration in our gut microbiota architecture. I have a question about your general opinion. Would you think that diversifying our gut microbiome would increase our resilience in terms of health to different chemical exposures? And do you see that biomonitoring the microbiome, in addition to biomonitoring the chemicals like phthalate, BPS, BPA, could be a potential means to improve biomarker identification in what's so-called precision medicine? Thank you.
No, absolutely, Panji. Very, very, very good question. I know biomonitoring is one tool in exposome. I told you also, we have to study transcriptomics, proteomics, microbiome, metabolomics. Why it's all important is because exposure and disease, we can find many effect biomarkers in between, but then if you add microbiome, transcriptomics, proteomics, it will make that link, right? We are trying to link exposure to a disease, but in between there are so many things happen that linking those two can be made possible with those microbiome, transcriptomics, proteomics. So we have to work with people in many different disciplines, right? So I am an environmental chemist, analytical chemist, health scientist. That's why now I'm working with medical doctors, trying to link exposure to disease, but we also need to work with epidemiologists, toxicologists, biologists, transcriptomics, all these kinds of people to make this research make a strong connection. Then we can prove, right? The science, we can make a strong evidence to show that some chemicals are really bad. Otherwise, always, if you tell industry, oh, no, our chemicals, no problem, no risk. It's only small exposure. So by working with many different scientists in many different disciplines, we can make this science much stronger. Yes, microbiome is very important. Obviously, if you take antibiotics, your microbiome can be altered. You cannot digest sometimes after antibiotics. That's why doctors prescribe you some vitamins to bring the microbiome back, right? So yes, microbiome plays an important role in transforming many different chemicals. So when we do biomonitoring, we have to take into all those factors in between exposure to disease. Very good question.
Thank you very much.
Okay, I think maybe one more question before I read the summary of this presentation. So the question is in the chat box. Maybe I direct to read the questions. So I would like to ask you some question. This from RC BRIN. So as you mentioned before that you use sophisticated analysis instruments. How, considering the simplicity of the analysis, did you also study and develop the biosensors for exposure analysis? If it is possible, what kind of biosensor which applicable for that purpose? Thank you. That's the question.
It's also a very important question, August. Biosensors are important. As you know, we use sophisticated instruments, very expensive. That's why these programs, biomonitoring programs, are popular in developing countries. I can give you some small example. To analyze one urine samples for phthalates, it costs $250, right? So in our biomonitoring study, population-based study, we analyze 5,000, 10,000 samples, which requires, 5 million, 10 million, $20 million. So our projects are very expensive because we use sophisticated instrumentation. It is a time-consuming process to process the samples. So simultaneously, in material science, in nanotechnology, those areas, biosensors are also being developed that will make this program practically feasible, cost-wise, right? So yes, currently that is still in very early stages. It has not, really gone, it has not reached to many engineers yet, because this is still a new program even for chemists and biologists and medical doctors. I'm sure it will eventually catch up with the engineers to develop sensors. And I think we should all be working with engineers. We should be talking to them to develop, sensors that can make these detections quickly and with low cost, technologies for assessing exposures. Yeah.
Okay, I think the time for discussion is finished. And before finish the session, I would like to allow me to summarize of the presentations. So it has been presented by Dr. Kanan that long-term, low-level exposure to a variety of toxic environmental chemical present in the environment can interfere with hormone function and contribute to the development of variety of diseases and health problems. And to address to the exposure to toxic chemical to which people are exposed and the amount of chemical in the people bodies, many developing nations have implemented nationwide biomonitoring programs. Biomonitoring is the direct measurement of people exposed to toxic substances by measuring the substances or their metabolites in human specimen, such as blood, urine, and etc. The biomonitoring program have been successful in informing the regulatory agencies on the health and nutritional status of the population, along with a variety of toxic chemical exposure. Biomonitoring is one of the important tools in the study of exposure, which is the totality of human environmental exposure from conception onward. Exposure complements genome and episomic is the study of exposure. And finally, several components of exposure, including external exposure and internal exposure, have been discussed very well in the presentation by Professor Kanan. I think that all that can I summarize. And before we close the session, I would like to invite Prof. Kanan to have a photo session and will give the certificate of appreciation. So for committee, please give us clue. Please smile, Professor Kanan.
Thank you so much.
So thank you very much for your very nice presentation.
Thank you.
Okay, thanks. That's enough. So this is the end of the presentation of the first speaker by Professor Kanan. And we would like to thank you very much for the speaker as well as participant for your kind participation. So I apologize for any inconvenience that may have caused. Thank you very much. See you then, and I will give back to the MC. Thank you very much.
Yes, thank you very much for leading the first keynote session, Dr. Agus. And for Professor Kanan, we are truly enlightened by your presentation. Thank you very much. To begin the next session, I would like to invite Dr. Wahyu Purwanta, who will guide us as the chair for the second keynote session. In the session, we will have Associate Professor Muhammad Aziz from the University of Tokyo, Japan. To Dr. Wahyu, are you already here?
Thank you, Mrs. Noor.
Yeah.
Good
Yeah.
morning, Dr. Muhammad Aziz.
Yeah, without waiting any further, the time is yours. Thank you.
Okay,
Please.
sorry. Good morning, Dr. Muhammad Aziz as a keynote speaker and all participants. My name is Wahyu Purwanto. I will be chair for the sessions. In the sessions, we will listen to a presentation from Dr. Muhammad Aziz from the University of Tokyo, Japan. Before starting, I would like to remind that all presenters are given 30 minutes for presentation and 15 minutes for question and answers. Before we start the sessions, once again, we strongly ask all participants to mute your microphone for duration of the sessions. If you have any questions, feel free to write your questions in English in the chat box during the presentation, as we will be having question and answer right after the keynote sessions, or simply click the raise hand button and I will give you a pass. Please write your name and who the question is for. Now we will start the session. I would like to invite Dr. Aziz, who will talk about highly energy efficient biomass and waste conversions to hydrogen towards sustainable decarbonizations. Previously, I first read the short biodata of Dr. Aziz. Maybe the committee can show the slide. Yeah. Dr. Muhammad Aziz is currently an associate professor at Institute of Industrial Science and the University of Tokyo. In April 2019, he has selected as U Tokyo Young Excellent Researcher 2018, promoting him for the current position. His general research area are advanced energy systems. He had published more than 175 peer-reviewed journals, 25 books and book chapters, and more than 200 proceedings. He got several fundings in national and international research projects and other collaborative research with industries and university. Well, okay, please, Dr. Aziz, you presented your material and the time for yours.
Okay, thank you very much, Dr. Wahyu, for very nice introductions. Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi for all of you. I am Aziz from the University of Tokyo, and it is my great pleasure to be invited today for delivering the talk. And as my background is basically mechanical engineering, and what we are doing now currently is correlated with the energy conversions technology. So for today, basically, I will talk about hydrogen conversion technology and how far we can take a look or figure out the hydrogens in our future. I think I have shared my slides. Can you check my slide over there, Dr. Wahyu? It's no problem.
Yeah, it's clear.
Okay, thank you very much. Okay, before I start my presentations for today, I just would like to introduce myself and also my lab over here in the University of Tokyo. We are focusing on the energy and process integrations. We are dealing especially with any kind of energy systems, energy conversions, hydrogen production, storage utilizations, and also some advanced technologies, including digital twin for the energy systems, also neural networks, artificial intelligence for that. So in case that you have any interest for collaborating with us, we are actually welcoming for all of you, whether for having any kind of collaborative research, visitings, students, researchers, or etc. So for the topics, I think you can access further in our website, epi.is.u-tokyo.ac.jp over here. Okay, as the backgrounds of our introductions of my talk today, as we could understand that currently we have this kind of energy systems in our current actually. So we have base load generations, and then it is followed by any kind of middle load generations because it is quite fluctuating, and finally. Because our demand also is basically fluctuating, means that the supply side also should be fluctuated or should be controlled or should be adjusted following the demands. So in conventional idea of our energy system, basically it is demand driven. So demand is driving all the energy systems in our conditions currently. So what is the problem over here is that we have huge dependencies on the baseload generations over here, especially based on the fossil fuels like the coals, natural gases, oils, or etc. And also, in case they would like to increase the share of the renewable energy, there will be any kind of huge curtailments in our energy system. So we just would like to minimize this kind of curtailment, because when we have any kind of curtailment, means that the capacity of the renewable energy cannot be optimized well. So what we are targeting for and how to afford that is that, and also how actually we can include any kind of biomass and also waste in our energy systems are things we need any kind of transitions for here. So as the phasing down, also phasing out of the fossil fuels for the baseload generations, so it means that the total amount or capacity of the baseload generation will be reduced significantly in the futures. And we are only having any kind of basically renewable baseload generation, including the geothermal, hydro, and or maybe biomass or etc. And after that, because it is not demand driven, so it means that we are balancing between the supply and also demand sides. So both of them, we must optimize them together. So in this case, because the adoptions of the renewable energy will be increased significantly in the future, so it means that we must facilitate them, although they are fluctuating. So we must minimize the curtailment of the renewable energy over years, and at that times we must have any kind of adjusting generations, and how far we can strengthen this kind of adjusting generations. So in these terms, in these conditions, we can understand that the cost or the price of the renewable energy will be the lowest, which especially the fluctuating renewable energy, including solar and also wind. And after that, it's followed by any kind of baseload generations. And finally, the prime or the highest price of the energy will be the adjusting generations, so or any kind of balancing services. So in case that we would like to adopt any kind of biomass or any kind of waste-based generations or any energy conversions based on this biomass and also waste, basically we must position or utilize this kind of biomass and also waste as the adjusting or any kind of energy buffer. So we can have any kind of prime price for this kind of resources, and also including the hydrogen also. So also, after that, we also need to talk about the circular economy and also issue related to the energy transitions. The big idea is that now currently we are in the transitions period, and I think it's very crucial. We are facing with several problems, including not only with the technology but also with the economic, with the social aspects. So there are many vested interests when we are transitioning from the conventional to the future energy system. And although we are considering that renewable energy will give any kind of solution to all of us, of things we must also rethink against that. Now we are only starting for another problems. Although we are targeting to have any kind of zero carbons or carbon neutrality in 2060 or after that, and now we are adopting massively renewable energy, we must also be careful that when we are adopting this kind of renewable energy massively, we are also will face with another new problems. Some studies also have reported that, like in case that in some areas we are adopting massive wind-based power generations, means that in some other areas there is any concerns that the wind speed will decrease significantly, and at times what is the problem is that there will be any temperature rise at the area. So how far we can actually still balance the environment and also with the adoptions of the renewable energy, while we're also maintaining any kind of another issues, including the social and also economic aspects. So circular economy is only one aspect. Maybe it cannot solve all the problems, and it is smaller than the SD and then the Sustainable Development Goals itself. But of things, although it is quite limited, but we can understand that how far we can minimize the input and also the output while we optimize this circular economy of our years, also the products, also the materials inside the community. So in our study, now we are still focusing on how far we have various primary energy resources. But the problem is that in our daily life, the most convenient energy forms are basically the secondary energy resources. It is more convenient to use electricity instead of coal, instead of natural gas, or etc. So it means that in the futures, I think the roles of the secondary resources will be much dominant compared with the direct utilizations of primary energy resources. So we should initially we should convert the primary energy resources to any kind of secondary energy resources. And the second aspect is correlated how far we can convert secondary energy resources among them mutually. So how far we can, in this case also, we have several aspects, we have several selections for the secondary energy resources, which is carbon free over years, including the electricity, and so for the chemical energy things, because for the chemical energy, we have only the option for the carbon and also for the hydrogens. So it means that in case that we would like to avoid any kind of carbon utilization, means that we only have the option for the hydrogens, or it is derivatives, including the ammonia, or etc. And also another option is the metal fuels. But unfortunately, the study regarding the metal fuels are still limited. Some countries, including Canada and also Netherlands, they are actively studying this one. But I think like Japan, USA, European countries, I think they are not so interested in this one. And also another option is the heat itself. So how far we can have this kind of mutual convection between them while we are optimizing the systems and also the energy efficiency. So regarding the biomass and also the waste itself, in this case, I think when we are like to focus on electricity and also the hydrogen-based energy systems over years, I think we have several options over here, whether the biomass or waste are converted initially to the electricity or hydrogens, and after that, how far we can have any kind of mutual conversion between the electricity and also hydrogens, and also the storage of the electricity and also hydrogens. So in this case, in case that we would like to retrofit the hydrogen, also ammonia utilization in our systems, including the biomass also or waste, we must have any kind of strategic policies over years to have any kind of, or to facilitate or to increase the economic performance of the waste or biomass itself. So we are not only utilizing the biomass or waste to provide any kind of basic energy supply itself, because the price at that time will be very low. So in case that we can have any kind of strategies or any kind of options for these utilizations, I think that's will be really excellent for all of us. Because the biomass itself or waste are basically, they are quite flexible, and they are also basically storable. So in case that we can use or utilize maximally this kind of characteristics, I think we can use this kind of biomass or waste as the prime, as the adjusting or any kind of buffer, energy buffer in our energy systems. And this is the mutual conversions of the secondary resources, but I think all of you also have understood well about this. In the futures of things, we believe that in case that we would like to increase the energy efficiency or total energy efficiency of our regions, our country, basically we must have this kind of policy. We are not letting each kind of energy forms to be independent, but I think it's really better to mutually connect and also integrate them together. So electric power or any kind of surplus electricity from the grid can be converted to any kind of gases-based fuels, including the hydrogens and also other fuels, and also vice versa. I mean, from the chemical energy or any kind of gas power or any kind of chemical fuels, we must also be able to copy them. It must be converted also to electricity. So why hydrogen itself? So the good things with the hydrogen is that it has very high gravimetric energy density, and also it is clean. But the problem is that the productions of the hydrogen is quite complicated also, and also quite energy intensive. And also another problem is that because it's low, it is volumetric energy density is very low, means that we need very efficient hydrogen storage technology. So that's the big issue why the cost of the hydrogens will be quite expensive. I mean, it is quite challenging to reduce the cost of the hydrogens, because in case that we would like to store and also transport the hydrogens, this kind of converting the hydrogens or storing the hydrogens using any kind of mediums or convert to any other organic materials or etc. Usually we need also additional cost for that. And but actually the utilizations of hydrogens are quite broad. Some countries are now not only targeting for the transportation. Transportation is only, or especially for the passenger cars, small scale cars, I think that's very limited. The big target for the hydrogen utilization itself is to replace the current power generations. So the energy export or import, which is currently conducted by using any kind of carbon-based fuels, will be replaced with any kind of hydrogen-based in the future. So we are not like in Japan, we are not importing further coals and also natural gas from other countries, but what we are expecting for is that after 2030, we can import the hydrogen-based fuels to Japan itself. And it will be utilized further, not only for the transportations, but also for the power generation and kind of industrial applications. So the problem is about the cost. The cost of the hydrogens currently is about, in case that hydrogen is produced from any kind of natural gas. So the total cost, I think, is about 1.5 or 1.6 US dollar per kilogram per kilogram hydrogens. The problem is that this kind of cost is very challenging for any kind of renewable-based hydrogen itself. So now currently the cost for the hydrogen-based renewable energy-based hydrogen is higher than $2 US per kilograms, or it is really ranging from 2.3 until 6 or something like that. So this is very challenging in case that we would like to directly compete with any kind of natural gas-based hydrogen productions. But I believe that as the technology also increases, and also there are some policy, including the carbon tax, we can imagine that in case that they produce the hydrogen from any kind of natural gas, means that the carbon tax will work over there. And in case that the carbon tax, although now currently is only about $2 US per ton CO2, but we need to improve that, because we need to compare also with the cost for the carbon capture technology. Until now, the cost for the carbon capture is about 20 until 30 US dollar per ton CO2, while we only have about $2 US per ton CO2 for the carbon tax. So it means that while we are reducing the cost for the carbon capture technology, we need also to increase the carbon tax in the futures. And I assume that in case that we can have about $8 US per ton for the carbon tax, we can increase from 2 to 8 US dollar per ton CO2. So the final total of the hydrogens, whether produced from the natural gas or from the renewable energy, I think will be quite competitive in the range of about 2.3 US dollar per kilogram of hydrogens. So this is also the possible roadmap for the hydrogens for the Indonesian case, because the condition is quite different with Japan's, Europeans, and also United States. We can start from any introductions of the hydrogen, which is quite ready for all of us. So we can start from any kind of domestic large scales, including the co-firing technology, including the blendings of the hydrogens to the existing diesel engines, or etc. I think that will be quite promising. Or maybe we can have any kind of dedicated power generation using the ammonia to replace the currently running natural gas-based power generations. So I think this kind of domestic large scale will be really promising for all of us, while we are not changing, while we are not retrofitting significantly the existing infrastructures that we have. The second steps after that, I think we can also take the opportunity for the export. We have created competitions with Australia, which is quite near with all of us. But I think in case that we can have any good or any promising technology and also policies for this one. I think the export for the hydrogen is also quite promising, because we have also promising demand for the hydrogen, especially in the Asian regions, including Japan, Korea, and also China. And also finally, in case that we have created or we have constructed any kind of infrastructures or sufficient infrastructure for all of us, finally, we can have also the domestics or any kind of small scale adoptions in our regions. And this is also the scenario that we thought together, we have discussed previously together. And I think we need to have any kind of progressive, but it should be adaptive. Because what, in case that we need to create or to achieve any kind of hydrogen economy in 2050, we must have any kind of progressive developments and also introductions of the hydrogen itself, including the demonstrations for the co-wirings and also for the blendings technology, and also some technology for the productions storing hydrogens. And also the big challenge is that during these periods, because we need also to facilitate the infrastructures for the hydrogen, whether for the production, storage, transportation, and also finally for the utilizations. And this is the potential sources for the hydrogens. I just would like to emphasize for the biomass and waste. I think this kind of resource sources are very promising for all of us, because we can produce the hydrogens for about 4.3 gigaton in case that all of the biomass and waste are utilized. But I think although we have about 20% of this, which is about, I think about almost about one gigaton per year, I think that will be a really huge potential for all of us. And I think this is also the initial possible scenarios for Indonesia. We have several resources, including natural gas, low rankle, and also some waste, biomass, or etc., and also hydrogen and also geothermal. But I put triangle for the natural gas, because I believe natural gas will be, I think it will have significant role during the energy transitions. So I think it is really better not to convert the hydrogen from the natural gas, but we should use any kind of other resources, including unutilized lowering coals like brown coal or etc., and also some waste, and also hydropower or maybe geothermal. And also for the storage transportations, I think we can have also another options, because we have also matched technology for the ammonia productions, synthesis of use. So I think compressions, liquid hydrogen, also ammonia will be quite really promising for all of us. And so for the utilizations, as I mentioned previously, utilizing the existing infrastructures, I think will be quite wise. So we can adopt this kind of hydrogen for any kind of co-combustion, or maybe replacing the dedicated natural gas power generations to be converted to any ammonia-based power generations, and then also blending the hydrogen with the diesel engines. And finally, in case that we have any kind of matched technology, and also the cost for the fuel cell and also electrolyzers at that time decrease significantly, we can adopt also for the fuel cell for any kind of distributed hydrogen productions and also hydrogen utilizations. And finally, also I think it will be about 2050 we can have any kind of dedicated hydrogen combustion technology. So this is the possible hydrogen trade from Indonesia to Japan, actually, because we must consider high competition with Australia. Things in this case, in case that we are transporting or storing the hydrogen in liquid and also ammonia forms, especially for the liquid hydrogens, the big concern is correlated with the boil of gas. So it means that the shorter period of the transportation or storage, I think, will be really compromising compared with the longer one. So I think in case that we can have any kind of competitions and from storage and also transportation aspects, I think Indonesia will enjoy better than Australia in this case, in terms that the demands or the customer itself is located in Japan, Australia, in Japan, Korea, and also China. So return back to the how far we can reevaluate and also revalue the biomass and waste in our energy systems. We must utilize their characteristics optimally. So basically, they are carbon neutrals. They can be stored they have good storability and also the flexibility. So we must utilize this kind of characters. So in case that we just use biomass and also waste to just to provide any kind of base power generations or any kind of base energy, I think the economic performance of the biomass and waste are quite difficult in this case. So how far we can utilize this kind of biomass and waste, integrate them not only for the power generation, but also for the hydrogen. So it means that we can use them for any kind of short to long energy supply. So I think this kind of short to long, short, mid, and also long energy buffer or energy supply, I think will be really, really nice in the future. So another option is also, which is correlated with the biomass itself, how far also we can do any kind of forestations. In our calculations, in case that we can have any kind of forestations in our...
Sorry, Mr. Rajesh, maybe 2 minutes left.
Okay. So this is the coupling for the forestations. And as I know that for the forestation itself, in case that we are doing, we have potential for about 12 million for the forestations. And in case that we are doing this kind of forestations, and yeah, it really depends on the stage of the forestations. But in case we focus on the initial 20 years, we can have the potential about 200 gigaton CO2 absorption. So it means that it is quite equal with the CO2 emitted by the total CO2 emitted by our coal power plants. And this is also some technologies for that, but I think I just would like to skip it because I have limited time for today. What I would like to introduce to all of you is this kind of technology, which is correlated with efficient productions or conversions of the biomass or waste to the hydrogen itself. We are doing with any kind of chemical looping technology, and we have 3 different reactors over here: reducers, oxidizers, and also finally the combustor. So what we have over here is that we would like to avoid any kind of direct contaminations of the nitrogens when the samples itself or the biomass or waste itself have reaction with the oxygens. So in these things, we use any kind of oxygen carriers, such as the hematite, magnetite, or etc., or any kind of other oxygen carriers. So in the reducers, finally we can convert the samples, which is basically C and H for years, to any kind of CO2 and also water or H2O. So in this case, what we are expecting is that we can separate the CO2. So in case that the fuel comes from the biomass or waste, basically we can have any negative CO2 generations. So after the oxygen carriers is reduced, we can have also another reactions with the steams over here in the oxidizers, and we can produce the hydrogens. So what we are expecting from this process is that we can produce the hydrogens while we are separating CO2 efficiently simultaneously. So we can have higher energy conversions, which is about 50% our calculations, and also in our study experimentations also 50% energy conversions, which is really promising because we are not only producing the hydrogens, but also separating CO2. And also some modified technology are also available. We are still working on that to also not only produce the hydrogens, but also directly produce ammonia. And this is also some productions also. In case that you are interested, you can check our publications or etc. And this is the last slide, I think. This is also the big things in our system is that in our issue, the current issue is that we need actually to optimize the operations of the biomass, waste, and also the hydrogen itself. So we are adopting any kind of machine learning in this case. So we are doing any kind of we are adopting any kind of deep reinforced learning to optimize, to find the optimized conditions. Yeah, it really depends on the target functions. But in this case, we are targeting for the economic performance.
Cuma diminta satu aja pertanyaannya.
Okay, so this is another challenges and each technologies. Okay, thank you very much, Dr. Wahyu, for your moderations today. And sorry for in case that I have longer time for the presentation. Thank you very much.
Thank you, Dr. Aziz. Very nice presentation. Now we will move on to the question and answer sessions. I will take a look at chat box first. Okay, from the committee, maybe for the session, just one question, Dr. Aziz, because of the time is over. So, question is from Mrs. Sinta Wardani. The question is a very interesting presentation and full enlightenment for H2 and H2 energy utilizations. How long do you think we can solve the problem with the storage device? And what do you think with the small device to use the energy directly on site? It's Dr. Aziz.
Okay,
Please.
thank you very much. I think Miss Sinta Wardani. Okay, thank you. And now we are still dealing with any kind of storage for the hydrogen, also for the ammonia. For the ammonia, I think it's really fine because ammonia has very mature technology and also infrastructures and also economy also. But the problem is that with the hydrogen, in case that we would like to have hydrogen's direct storage, or it is not converted to ammonia. So in our calculations, it really depends on the utilizations. So in case that we would like to utilize high purity of the hydrogens, means that liquid hydrogen is much promising. And it is also quite competitive with the ammonia itself. Hydrogen liquefaction, the problem with the hydrogen liquefactions is that it is the cost, and also it is very energy intensive. Yeah, some countries, including Japan and also Australia, they are developing this kind of technologies to transport the hydrogen produced from the coal from Australia to Japan. But we are still waiting on that. And in 2025, we are expecting that we can have any kind of massive transportation, conversion, also transportation of hydrogen in liquid forms. The technology itself is quite matured. But the problem is that in case that we have any large scales, how much the large scale effect can impact the total cost of that. In our calculations, we can have about quite competitive, which is in case that the hydrogen finally converted to the electricity. We finally, the total cost of the hydrogen converted or stored in liquid hydrogen is only about 22 cents per kilowatt hours. And also it is quite similar, although ammonia is quite promising, it's quite lower. It is only about 19 cents per kilowatt hours. But I think that both of them are quite competitive. And in the futures, how far we can have more energy efficiency in this case. So there are some other options for the small scale, including the metal hydride. So in case of the small scale for the transportations, we can have any kind of transport compression technology and also metal hydrides. And also another option is liquid organic hydrogen carriers. But unfortunately for the liquid ones, both gravimetric and also volumetric energy density are very low. So I think the economic performance in our calculation also for the liquid organic hydrogen carriers, like the tall ones or etc., I think will be much higher compared with the liquid hydrogen, also the ammonia. Thank you very much for your questions.
Okay, thank you, Dr. Aziz. Maybe from me, but you have to answer the short answer. Yeah, is a renewable hydrogen profitable, Dr. Aziz?
It really depends on the times.
Okay.
So in case that we have any kind of surplus power for the renewable energy, because renewable energy is basically fluctuating, so I think there will be any kind of huge surplus in the future. So in case that we have any kind of excess power or excess energy from the renewable energy, we can have quite competitive or good economic performance of the hydrogen itself.
Thank you. I think the time for this session is up. Now I will summarize this session. Basically, hydrogen as a fuel cell has quite a promising prospect, especially regarding the absence of greenhouse gas emissions and the high energy efficiency in its products. Hydrogen production process is generally pursued through the method steam reforming, and this is the modes, gasification, electrolysis, and biological processes. Biomass and waste in particular are potential source of hydrogen, but in practice, there are still some challenges, such as a fluctuation availability, and technology readiness. On this occasion, Dr. Aziz conveyed a new technology called chemical looping hydrogen production. The chemical looping hydrogen production technology has three circulate reactors, including reducers, oxidizer, and combustor. An oxygen carrier is utilized as the medium to transfer oxygen and heat among the reactor. Before we close the sessions, I would like to invite Dr. Aziz for a photo session, and we will present a certificate of appreciations. For the organizers, please give us cue. Enough? Okay, thank you. So this is the end of the session. Thank you very much to the keynote speaker and participant for your participation. I apologize for any inconvenience this may cause. Thank you very much. Bye. I'll give this back to the MC.
Thank you very much.
Okay, thank you very much for leading the second keynote session, Dr. Wahyu. And to Dr. Aziz, we are truly enlightened by your presentation. Thank you very much. And then to begin the next session, I would like to invite Professor Suhendar Sahumar, who will guide us as chair for the third keynote session. So in this session, we will have Dr. Kwon Young Kim from the Green Technology Partnership, South Korea. To Professor Suhendar, are you already here?
Yes.
Okay, without waiting any further, the time is yours. Please, thank you very much.
Okay, thank you, Ms. Nur Kamila. Good afternoon. I think Dr. Kwon Young Kim is already here.
Yes, here I am.
Yes. Good afternoon, Dr. Kwon Young Kim. So may I call you Dr. Kim? It's okay?
Yes.
Okay. Okay, good afternoon, Dr. Kim and all participants. My name is Suhendar Sahumar from Research Center for Environment and Clean Technology of NISA, National Research and Innovation Agency. I will be a chair in this session. So before start, I would like to remind you that the presentation are given in 30 minutes and question and answer in 15 minutes. So before beginning the presentation, again, we profoundly request to all participants to mute your microphone. If you have any question, please write down your question in English in the chat box and during the presentation, or click raise hand button during question and answer right after the presentation. I will give you the permission. So now we will begin the presentation, but I would like to invite Dr. Kim from Green Technology Partnership of Republic of Korea, who will be talk about ASEAN ROK green transition and carbon neutrality joint response and its sustainability governance establishment and implemented strategy development. So before the presentation, I will read the short biography of Dr. Kim. Dr. Kim Kyung Kim received a PhD in Business and Technology Management from KAIST in 2015. He was an adjunct professor from Business and Technology Management, Department of Industrial Management, Korea University of Technology and Education, Korea. Currently, he is a director of Green Technology Partnership Initiative Korea, Institute of Science and Technology Korea. He is also as a senior researcher of the Center for Climate Technology Corporation. He has many international and domestic teaching experience. His research interests in green and climate change, renewable energy, solid waste management. He has also interest in organizational and professional commitment, organizational and professional identification. So now, please, Dr. Kim, for the presentation. Time is yours.
Thank you very much. Thank you very much. Park, you good kind introduction to all of us. My name is once again Kwan Young Kim. So today, very honorable that I got time to share my idea. The title is about the ASEAN-Korea Green Transition, Carbon Neutrality Joint Response, and how to do sustainable cooperation, government establishment, and implementation for the carbon management, circular economy. This is our main issue between two countries, Indonesia and Korea and Indonesia. Specifically, I would like to share how can we develop the smart green technology cooperation perspective of the Korea, ASEAN, Korea, Indonesia, Korea Green Technology Cooperation. Our center, this is my headquarters. I'm the working for Green Technology Partnership Initiative in Indonesia. My center located in the Serpong, Puspitek National Science Technology Park. Also, with cooperation bilateral with your BRIN, also the other many your government, Bapenas, Ministry of Science, Ministry of the Environment, the Forest, and also the other your main Ministry of the Agriculture, Industry, Energy, and Natural Resources. This is a main your government correspondence about the carbon management, carbon neutrality. I'm also working for Green Technology Center as a senior researcher. I'm also involved in there are many projects with the Korean government, Ministry of Science, ICT. Our GTPI Center was established in 2019 before Corona-19. We started our cooperation with Indonesia. At the time, the former BRIN. We got a cooperation with in terms of the knowledge sharing, information sharing, capacity build-up, also demand deduction. Demand deduction means that how can you do policy assistant, technology assistant about the green technology. Also, we try to technology demonstration, technology deployment into Indonesian site. Using there are a lot of the successful advanced technology proven green technology center, green technology from the other Korea Government Research Institute, such as KL, Korea Institute of Energy Research, Green Technology Center, and also KIST, Korea Institute of Science Technology. This is the main biggest, main Korean Government Research Institute. This is our center started since 2019. We got a cooperation with the Indonesia government, bilateral, also multilateral cooperation with the ASEAN Secretariat located in Jakarta, the ASEAN Secretariat, also ASEAN Mission. ASEAN Mission means.
Excuse me, Dr. Kim, your PPT not move.
Okay, I know. This is just introductory about.
Yeah, just introduction. Okay.
So our center is a cooperation with the bilateral with the Indonesian government, also multilateral with the ASEAN member country, 10 member country. Okay, anyhow, this is the main contents. Climate change, climate crisis, and Korea green growth approach and challenge. And also, I got many understood the Indonesian vision and mission and the green growth. And also, how can you do approaching to the ASEAN Korea Technology Cooperation? And finally, what are you going to do forward ASEAN Korea Smart Green Technology Cooperation in terms of the GTPI? Okay, this is the many of you guys already well about this information. Due to there are a economic world forum, they say green global risk report 2021, they said climate environment issue is a top global risk such as extremely weather changing, climate change, right? Or climate action failure, even though try to successful carbon neutrality, carbon management, but anyhow, there are many action was not successful. Human environmental damage also happened to our as a risk. Another one is the biodiversity loss problem, as well as the natural resource crisis problem. This is a 5 or 6 the main globally biggest risk due to it's like a World Economic Forum, they said. This is our assignment to solve the problem as a global issue. From the mass production, from the mass consumption, under the assume that energy resource are infinite, but many of you guys already know about we have to do pursuing growing green growth.
Adik Umel. Ni adik Umel satu. Yang ni adik Umel nenek. Ni adik Umel nenek. Adik Umel.
Okay. Anyhow, we have to forward to pursuing green growth. Growth through the conservation of energy, conservation resource within the range that Earth economy can withstand. This is our current situation we have to do. Okay, let me pass. Another one is that we can do compare two OECD country and non-OECD country. Non-OECD country that are totally depend on the fossil fuel continue to increase sharply by 2050. Can you see the increasing fossil fuel dependency of the non-OECD? Much more compare the OECD country, non-OECD country growing to many portion of the fossil fuel. Compare with the coal, oil, gas, especially especially the coal to 1990 is coal to 28.27 to 2017 already increased 35.27. Compare that the OECD country not increasing, the gradually decreasing about the fossil oil. That's why I think it is possibly not possible to overcome climate crisis when developing countries adopt energy intensive carbon emission economy growth. What I want to say, not only R&D, but also RD&D, research development and demonstration. Demonstration means a deployment from the R&D performance into localization. That is mean the technology transfer, technology commercialization from the advanced country to developing our partner country. So what I want to say, key and solution, the development of the diffusion of the green technology. So my headquarters is Green Technology Center. Very much generally concept meaning Corporation Green Technology Center. Anyhow, we are identify transfer technology, green technology from the Korea to Indonesia, from the Korea to ASEAN member country. This is our role and responsibility, our vision and mission. So like this, the right side, the photo projection of the energy consumption non-OECD country. Many of the ASEAN member country, including Indonesia, that are from the Myanmar, Thailand, even in Singapore, also they are green growth cooperation, commercialization, transfer is needed for the reducing carbon anyhow, the carbon management, carbon neutrality. This is a concept we want to cooperation with you. This is a very much should compare the Cheonggae 1960. Also compare with them the 2021 in Seoul, Korea. At the time, 1960, the Korean GDP is only $100. But to improve after 20 years, we increased the GDP. Is near to the 2000. Now 2021, we are almost to 45,000. Right? This is so it's a Korean. It's a very practice for the sharing development experience of the green growth global community. At the time, nothing there, but we have to do compressed growth using science technology, especially green technology and green growth approach. Nowadays, in the center of the Cheonggae in Seoul, Korea, they can enjoy the walking with the brooks at the Seoul center of the Korea. So I want to share with you Korean experience of the development also green growth approach. But one thing is very important thing. Nowadays, there are many countries facing about the job risk growth. This is a very much difficult situation. Growth, but job risk growth. This is a currently global issue, right? So we have to do green growth with the job occupation. As well as increasing the job occupation, as well as green growth, without job risk green growth. This is our concept I want to share with you. For your understanding, the Korea government 25 affiliated research institute. However, in Indonesia, BRIN, this is the biggest one conglomerated the government's research institute under the presidential office. However, 40 years ago, we started our own government research institution, that is the KIST, Korea Institute of Science Technology. This is the only one conglomerated government affiliated research center. But nowadays, spin-off from the one KIST, nowadays spin-off to the other specific energy research, electric research, chemistry research, mechanical research, like this 25 affiliated research. This is a total researcher member, 12,000 researchers. This is almost compared with the BRIN and the Korea Government Research Institute. Almost of them, same situation, same quantity. And also we have the 5 Science Technology College Institute. This is a Korean, there are 25 Government Research Institute, 5 Science Technology College, they are ready to R&D, and then R&D and demonstration, RD&D, another one human research development, and the capacity build-up with the partner economy. Compared with the another foreign country, Korea is the second highest R&D ratio to GDP. Number one country compared with the GDP, Israel, there are much of them, 5% of the GDP, they input the R&D national level of the research and development. The second country is the Korea, so Taiwan or South, and the Sweden, and Japan, and Germany, and US. This is a portion of the R&D and the input to compare with the GDP. Out of the 25 government research institute, you can see the Green Technology Center, one of the 25 Korea Government Research Institute. This is a KERI, KARI, KIMS, KOIM, KIST, KRIS, KIST, NRFI, CRIS. There are a lot of this is a Korean under the Ministry of Science Technology, Government Research Institute. I want to focusing on the green growth. Under the green growth, there are Korea three kind of the very much it's like a core institute we have. First one is you can see this one, Green Growth, Global Green Growth Institute. This is an intergovernment organization, right? Another one is the climate changing, response to climate changing, Green Climate Fund on head. The another one is the green technology approach. We have the Green Technology Center. GGGI is approaching to in terms of the policy diagnosis. GCF is in terms of the financial approach. And also GCT, Green Technology Center, we are approaching with the technology approach. When it comes to think of the new project development, we have to think of the four kind of the approach. The first one is the policy. Second is the technology. Third one is the project development. The last but not least, we have to concern about the finance. This is the fourth thing we have to concern when it comes to develop everything. So GGGI is approaching by the policy approach. GCF is the finance. GTC is approach to technology. Through kind of this triangle cooperation, we can make a new project development with the partner country. For the green growth, we have to do approaching positive cycle between the environment and economy. Economy means circular economy. Another, we have to do meeting international green growth expectation. Another one is we have to improve the quality of life and the revaluation of the green living. This is the approaching three triangle green growth in Korea by the focusing on by the Korean government. Continuously, GTC support to green growth strategy we have. Currently, we are now third national green growth strategy, 2019. From them to 2023, we are now set up the green growth strategy we got. We already got the first and second national green growth strategy set up in terms of the technology international cooperation. This is a GTC approach with the partner country, especially Indonesia. We got it's like a many specific.
Iya, Pak. Ini lagi nyari.
Sorry. This is Indonesia. We got many cooperation. It's like with the cooperation local government, also central government. We got it's like eco-friendly smart island development. It's another one is the master plan for the manpower systems, something like this. The Indonesia cooperation we got. Another one we got a cooperation with the Indonesia. Research on the finding on the climate technology RD, the demand to promote the Korea-Indonesian cooperation. Also establishing of the approaching the technology center for low carbon integrated waste management. Our center is started owned by the integrated low carbon waste management development with Indonesia. This is our GTPI core concept. The second thing is I want to share with you. This is throughout who is the president, regardless of the government region, the green growth policy continue to be pursued regardless of the change in the presidency. 2008. We got a national RD&D midterm long-term master plan for climate change adaptation. At the time, our President Lee Myung-bak, he managed leadership for the green growth approach. At the time, our GTC establishment in 10 years ago. Even though the change of the regime in the Korea government, another regime, another President Moon Jae-in, is President Yoon Suk-yeol. We are now, anyhow, who is the president? We pursue continuously the green growth policy and sustainable development. This is a Korean situation. Look at this one. Indonesia, not only Indonesia, but also all ASEAN member countries proclaim that pursue the 2050 carbon neutrality strategy, also 2050 long-term low greenhouse gas emission development strategy. Recently, last month, Korea, Indonesia, we got a bilateral net zero technology forum we got. Last month, there are 17 and October, we got the bilateral cooperation. At the time, Indonesian NDC, Indonesian LEDS, specifically Indonesian LETS, Korean LEDS, also proclaim their own the vision and mission, how can a strategy response to climate change for the carbon neutrality 2050. In Korean case, we got a four kind of the policy direction: low carbonization economy, low carbon industrial economy, just a transition to carbon neutral society, and another one is a strengthening the carbon neutrality system. LEDS, due to the LEDS also main direction, such as the expansion use of the electricity, hydrogen, innovation in energy efficiency improvement, use of the future carbon removing technology, okay, using the mitigation adaptation.
I'm sorry, Dr. Kim, your time is 4 minutes left.
How many minutes, Park?
4 minutes left.
Only 4 minutes?
Yes, left. Yeah.
Oh my goodness. Okay, please let me speed up, please. Okay, so greenhouse gas emission mitigation, we have to approaching to generation, industry, transportation, building, electricity. So we have the solution. Transformation, commercialization, technology innovation for transformation, policy innovation, social innovation. Korea, we got 10 kind of so it's like a R&D project planning. 10 carbon neutral core technologies such as hydrogen, solar power, wind power, bioenergy, industrial byproducts, recycling, industrial process efficiency, secondary battery, building efficient, digitalization, CCUS. This is a 10-hour carbon neutrality future technology want to share with you, want to transfer technology to Indonesia from Korea. How can it enhance the green growth? We have to minimize negative environmental impact. We have to less use of the natural resource. We have to improve the economy, social religions to natural hazard. We also advance social infrastructure. We also strengthening natural asset. It's like economic activity, natural capital. We have the circular. We have to. It's like a interconnectivity policy and the infrastructure, technology, policy, finance, project, capacity build-up, platform development. It's like a 5 or 6 new the core concept. We have to circularly interconnected. This is a green transition with inclusive adaptation. Inclusive adaptation. We have the formulation green transition facility vehicle to secure the inclusive adaptation to new economy framework. This is our adoption, inclusive adoption for the green transition. Okay, this is the main concept for I want to share with you. Speed up. How can you do transfer technology? First, we have to identify needs. Second, we develop the customized bankable project. Bankable means the private investment, public investment should be into the project. Third one is we have to alliance the network, technology assistance, finance. I told you 4: policy, technology, project, finance. This is, we have to alliance 4 kind of approaching for the implementation. This is very much our concise the concept for technology transfer from Korea to Indonesia, from the network, assistance, technology, policy assistance, finance, implementation. However, we got very much the scale up in gap in scale up, improving from the feasibility study. After that feasibility study, move to implementation. There are big gap, big divide. We have to scale up in divide the gap like this. How can you do? That's why we need them RD&D with the financing approach. That's why we need the holistic approach: technology innovation, social innovation, finance innovation, policy innovation. This is a 4 kind of innovation. It's like based on the innovative climate action. I understood your president, it's like NDC proclaim mitigation action, global commitment, national commitment through the based on the commitment emission reduction 2030, 2050, energy, is a forestry, waste sector. I understood it's like 6 strategy. One of them is the green economy, right? The other strategy, 1, comparative human resource, economy, productivity, digital, capital city movement. Is like very much important. I want to focusing on the green economy, low carbon economy, circular economy, blue economy, energy transition. Also, we have to understand the RPJMM. This is a 7. It's like approach with the long term, the green growth approach, right? Anyhow, I understood your Indonesian approach. So finally, I want to share with you. Just give me the 2 minutes, please, Park. This is your strategy to achieve the low carbon development from the energy sector, waste sector, forestry sector, industrial sector. I want to share with you. This is it's a very important thing for your municipal solid waste approaching. It's a BRIN, the geostack. This is a landfill. Your current situation. Currently, high carbon waste management from the source transfer landfilling, but we have to suggest like this the low carbon approach. It's like compare with them. This is the only source transfer landfill on the retail recycling, but we have to propose like this one. Source transfer waste energy from the arm A, B, C, D, E, F, G, H for the better efficient management, waste reduction in greenhouse gases, better landfill management, innovative finance. This is it's like I want to propose with you. Source segregation, transfer from the source to the food waste recycling, transportation from the source to temporary transfer installation, operation, also 1 more transportation, recycling facility, 1 more transportation, waste energy facility. It's like RDF plant, maybe landfill reclamation. Like this, though, I want to share with you, want to develop the new project development between the country. Currently, there is who is the?
I'm sorry, Dr. Kim, your time is up. Maybe you can finish on one more minute, maybe.
Okay, please.
For conclusion, maybe.
Okay, please, 1 minute. Sorry about that. From the municipal solid generation, finally, this is energy generating from the waste, landfill gas collection, landfill mining, power planting, cement paper industry, recycling, farmer. In order to making the energy, we need to write this the pre-treatment technology, mechanical biological treatment, composting, vermicomposting, biogasification, mechanical recycling, technical chemical recycling, upcycling. Like this, though, we have to transfer the technology from the Korea to waste. In order to not only Indonesia, but also we extension to ASEAN member country. So this is the 10 member country project. It's like almost 8 million US dollars for the restarting next year for the 3 years. 30, it's like a 36 months, right? This is it's like a policy development, something like that.
Yeah.
Okay, I'm done. Anybody the question? Let me respond to you.
Okay, thank you very much, Dr. Kim. It's very interesting talk about the green technology and how to reduce about the carbon emission by using and developing of green technology. But unfortunately, the time is not enough for your presentation. Maybe we can continue with question and answer, but we didn't look any question in the chat. Please, if is there any question, to click hand raise button. Yeah. Is there any question from the participant? Okay, maybe may I ask you to reduce the carbon emission? Actually, what is the priority program actually should be established or developed in the world? Maybe the first question. So the second question is to cooperate with the Korea ASEAN country, especially for the Indonesian scientists. What's the interesting of the priority program maybe for cooperation with the Korea, and how's about the funding source for the research cooperation come from? Maybe you can explain it about it.
Oh, sure. This is we're approaching to mitigation and adaptation. Not only that mitigation, but also there are voluntary carbon decreasing approach. There are many approaching from the government, not only government, the other company. There are Korea, there are several companies that are trying to, it's like a carbon management with the corporation. So we have to think about the ITMO. It's like the trading system of the carbon between the country. So our Korea is approaching to partner country, establishing the ITMO system, ITMO policy bilateral approaching. But the Indonesia now, we recently in Bali, it's like G20, they also discussion with the Minister of the Environmental, the Korean, discuss with the carbon trading approach. Also recently you made the law environmental of the Ministry of Environment and Forestry from Indonesia. So we trying to share our technology transport to how can we mitigation, how can adaptation, voluntary approaching. Not only that, but also we have to use the finance, GCF finance. Also, we got a Ministry of Finance Economy. We got a trust fund for the ASEAN member country, specifically for the Indonesia. This is I want to share with you. GCF fund, Korean Ministry of Economy Trust Fund. Another one is the ASEAN Korea Cooperation Fund. Three of them from the Ministry of Economy and Finance, Ministry of the Foreign Affairs, also Ministry of the it's like Science, Technology, and ICT. Three of the finance, we are ready to support you. However, we have too much more discussion with the policy and technology for the new project development. New project development is like based on the cooperation discussion with the local government capacity builder. So we now discussion with the BRIN not only BRIN, but also BRIDA. BRIDA means also the cooperation, local partnership for the developing local government. Recently, one more thing we do now on the way to sharing is like a policy loan to Indonesia. Policy loan means another one is the green productivity city policy development. So this is just like a comment from fund. It's like a trust fund economy, ASEAN Korea Cooperation Fund, also GCF fund. This is we are ready to cooperation with you. Hello, Park. This is one more example of the ASEAN Korea Cooperation Project.
Okay, I think there's some technical problem with Professor Suhender, so I'm gonna lead the session as temporary. So yeah, I think you still have 1 more minute for finishing your session, your presentation. Yes.
Okay, thank you for your 1 minute. Okay, this is one concept. This is from the municipal solid waste. We have to do technology assistant, mechanical, biological, upcycling, and then finally we can do change it from the waste to RDF waste, composting waste, LEBA, it's like a black soldier flyer, electricity, pellet development, liquid fuel. It's like a various RDF plant from the waste. We can do change it from the waste to like this the energy development. This is a successful project development from using the ASEAN Korea Cooperation Fund. This is a fund we're focusing 4 kind of the approaching, strengthening, coherence. It's like a policy technology assistant. Second thing is the project development. What is the priority project using develop the waste to energy? The third one is the knowledge sharing, the capacity build up. The last one is the development of the platform. Platform means it's like a decision making approach using all kind of the policy, technology, project, finance, capacity building. Like this 4 kind of the component from the using ASEAN Korea Cooperation Fund. This is a totally we got a approval from the Ministry of the Foreign Affairs. We will do start January, February next year for the 3 years. I'm strongly recommend your approach to cooperation with the specifically Indonesian project development. This is the platform. It's a Korea ASEAN Integrated Green Technology Platform. Using this platform, you can do transport technology, local development, capacity build-up, demonstration, market entry. We have to support you. Also, technology commercialization between the countries. Like this, the platform. Finally, we support them to startup development for the company of the Indonesia. We also startup development for the stakeholders from Indonesia. So,
okay, Dr. Kim, I'm so sorry, but your time is up. Yeah, okay. So, do you want to summarize your presentation just for 1 minute?
Okay.
I mean, like, okay.
Okay.
Just for the summarize. Yeah.
Okay. Only
okay,
just
1 minute.
Okay.
Yeah.
GTPI has got acknowledged by the between the country, Minister of the Foreign Country Indonesia, Minister of the Foreign Country Korea. 2021, June 25, two ministers sign up for the plan of the action for the implementation special strategic partnership between two countries. Within the plan of action, GTPI was acknowledged designated research and development green technology partnership between the countries. So we are ready to cooperation until 2025 for the cooperation green technology, policy, finance, capacity build-up, and also information sharing with you. So now we focal point Geotech, also LCA, also they are the renewable energy partner. So anyhow, we are ready to cooperation with you much more. Please propose your new project development. We are ready to cooperation discussion. We do more cooperation with you, more and more without break. This is my last comment. We are ready for.
Okay.
Thank you very much.
Thank you very much for your very engaging presentation. To end the session, I would like to present you the certification of appreciation. So yeah, thank you very much to you, Dr. Kim, who already given us such enlightenment projects between Korea, Republic of Korea with Indonesia. And I hope in the future we can collaborate more on the projects that you mentioned previously. Okay, thank you. And then we will have a photo session for us as well. So 1, 2, 3. Okay, thank you very much for your participation, Dr. Kim. Yeah.
So sorry about the time management. So sorry about
Oh yeah, that's not a big deal. Okay, we're sorry too for the technical problems that we face in today. Thank you very much for your presentation. It's very interesting as well. So yeah, so we will move to the next session. So next, to all ladies and gentlemen, before we proceed to the next oral session, we will have a break for 5 minutes. So please enjoy the video.
Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born.
Yeah. Welcome back, ladies and gentlemen. Before we proceed to the next session, I would like to remind to all participants, kindly fill the attendee form through the link that is provided by the organizing committee in the chat box, since it is required for sending the e-certificate. And for the first oral session, we kindly invite Dr. Widyarani as moderator and also all speakers for this session. I remind you all, for any question, please type or write down in the chat box during the presentation, or simply click the raise hand button. We will have Q&A right after each session. Please write your name and for whom the question is. So, Dr. Widyarani, are you already here? Okay.
Yes, Dr. Amelia, thank you.
Yeah. Without waiting any further, the time is yours, please.
Okay. Thank you, Dr. Amelia, for the time. Good morning, ladies and gentlemen. My name is Widyarani. I will be a chair for this oral session. In this session, we will have two presentations from three presenters. Before we begin, I would like to remind all the audience to mute your microphone. If you have any question, you can write down your question in the chat box, or you can click the raise hand button. Okay. For our first presentation, we will have Dr. Akira Sai from Hokkaido University. Dr. Sai will present his research about psychological distress among urban slum sanitation workers during COVID-19 pandemic. Dr. Sai, are you ready?
I think so.
Yes.
It's good to see you.
Okay.
Dr. Widyarani.
Good to see you too. Yeah, the time is yours.
Okay. Thank you very much. So please allow me to share my screen first. Please wait. Is everything okay? Can you see my screen?
Yes, it's okay. Yes, we can see it.
Okay. Good afternoon, everyone. Well, still selamat pagi to Indonesian friends and colleagues and distinguished guests. And my name is Akira Sai, and I am from Hokkaido University, Japan. And first of all, I'd like to say a huge thank you to organizing committee members for making this happen, and also allowing me to be part of this fantastic online symposium. So today, I'd like to talk about psychological distress among the sanitation workers who are working in urban slum, especially during the period of the COVID-19 pandemic. So first of all, I'd like us to go through the background so that we can have a better understanding of what I'm telling. And then we are going to the following sections. So first of all, I'd like to talk about the general issues that happen in developing countries. So as you may know, sanitation generally refers to a safe management of human waste. Human waste, but at the same time, in its broader term, it contains solid and animal waste. And especially in low and middle income countries that are dependent on the informal sectors of garbage collectors, due to the lack of sophisticated sanitation infrastructures. The waste issues have been a massive challenge. For example, especially during the time of COVID-19 pandemic, we could easily expect a massive amount of unsegregated waste, for example, biomedical and household waste, and also those who are working in the areas are known to engage in their work and without personal protective equipment, so-called PPE. And so this will place them at a greater risk for example, like cut wounds, respiratory and infectious diseases, and on a daily basis. At the same time, a sense of being getting accustomed to the work in these well, let's say in horrible work environment, and it can contribute to even greater further risk. But I'd like to emphasize here that, besides the physical health, due to the nature of their work that requires daily contact with waste, stigmatization against the workers has also been an issue, which is understudied and under-recognized. And it's not limited to sanitation workers, but also healthcare workers such as doctors, nurses, all those who are working at the front lines of COVID in this fight. And they have reported higher levels of being stigmatized by their members in the community, and which ultimately leads to a lower self-esteem and challenging of a constructing of positive identity. So in the end, all these psychological distress could lead to a further erosion of mental well-being. So this will also affect their long-term work performance. So I'd like to explain a little bit about the nature of the garbage work. So garbage work is so-called dirty work in the context of sociology, because it's dirty in many ways. For example, it's physically dirty. As you can imagine, the workers, and they engage in waste picking, waste collection, waste sorting, and obviously they can have daily contact with garbage and all other things. And also the job is socially tainted because of the servile relationship to others. And also at the same time, because of the definition of cleanliness and purity. And this job also contains, our job is also morally dirty. So let's summarize that. The garbage work is definitely physically, socially, and morally dirty in a sense. So I'd like us to go through a little bit about our previous findings back in 2019 before COVID. So at this time, and we sought to examine the personal hygiene behaviors and work-related values so that we could have a better understanding of what these people are doing on a daily basis, what they think about all the issues that are happening at their work site. So this was the previous study was conducted in 2019, so in the summer season. And the study site was in Bandung. At the time, we specifically targeted 7 garbage workers, and we conducted both quantitative and qualitative studies. So, for example, like based on the interview, the most unknown issue was found to be odor, as you can see here. Wetness, and followed by odor, dirtiness, others. And the most hazardous waste was medical syringes, followed by the broken glasses, the scores, and finally, the most disgusting issue was animal corpse, and also menstrual products. And as you can imagine, this work site, it's not really organized. As you can see, a variety of waste are like scattered everywhere, and the workers, some workers, they engage in waste sorting without personal protective equipment, such as like gloves and things like that. So if we could take a look at the change between the past and present, and for example, and before and they started the job, or after they started the job. So as you can see, and in terms of wetness, now at the present, they don't really seem to care, and we could also say the same thing about the issues of smell and dirtiness. So this is a scene taken from the garbage work. I actually also participated myself in trying to understand the real situation behind the garbage work. So in terms of the personal hygiene behaviors, so in terms of safety, most of the people realize that it's a danger in dealing with all kinds of waste. At the same time, in health risk as well. However, in the situation is that these workers, they're engaging the work without personal protective equipment, as I explained in the previous slide. As you can see, the man eats something with bare hands without hand washing. And this could have been consistent during the COVID-19. And also, as you can see, some workers, they engage in work with short pants and flip-flops, which allow them to get exposed to various kinds of waste. And the reason why they don't wear personal protective equipment is because of physical discomfort, such as itchiness, body heating, and work inefficiency. And but the current situation may place them at a greater risk and for increased exposure to physical health risk in the long term. And also, from findings by interview, so we extracted some negative voices from the workers. For example, some mentioned that they do not receive any appreciation from the community members. And also some people, they underestimated the job. At the same time, they reported that they were aware of these problems, such as Yes.
Yeah, Dr. Sai, excuse me. You have 1 minute to wrap up.
I have 1 minute to wrap up.
Yes.
That's okay. Okay, so that's not what I heard actually. I thought I had a 2 minutes presentation.
Okay. 15 minutes for presentation and 5 minutes for Q&A.
Okay, thank you very much. Okay, so which means I have to rush. Okay.
I'm sorry.
Sorry. So it was hypothesized that this COVID situation, especially during this situation, would bear fear of contact with virus and also social stigma against garbage workers, especially among the workers without personal protective equipment. And also workers without PPE who report a greater fear of COVID-19 and of appearance evaluation, and also followed by a greater psychological distress like anxiety, depression, lower self-esteem, and lower quality of life. So based on these backgrounds, we set specific objectives to evaluate the prevalence of psychological distress and its severity, particularly in terms of anxiety and depression, and also to investigate its correlates among both street cleaners and garbage workers. So the study was conducted in 2022, and we targeted 60 workers, but the questionable and the usable questionnaires were returned by 56 sanitation workers, which means 39 street cleaners and 16 garbage workers. So in this study, we conducted a questionnaire survey about psychological distress, and also we did some observation. So these are the questions that I use. I use the questionnaire to evaluate the appearance, fear, and also COVID-19 related fear, and self-esteem, and anxiety and depression. So let us quickly go through the results and discussion. So this is the demographic characteristics. So according to this data, as we can see, those at the age from the 45 to 54, 55 to 64 comprises a large part of this work population. And about street cleaners, 39 street cleaners and 16 garbage workers we targeted. So in terms of the gender, which I forgot to mention, that most of these works seemingly conducted by males compared to females. So, so this is about the prevalence of psychological distress. If you could take a look at the red part. So I broken down this in a table by total and street cleaners and garbage workers. So in terms of the anxiety and depression, these things can be broken down by each level. So what is the most striking thing was in depression. So as you can see, we could witness that many members have the symptoms of the depression. So the scores over 10 means that they have a moderated depression. The severe one means they have a score over 15. Severe 2 means over 20. So compared to anxiety, depression situation is more serious. So, and also broken down these psychological distress by age range, and according to this finding, these issues were more prevalent among the workers at the age of 35, 44, and 45, 54, and 55, and 64. And also, well, in terms of the mean scores of COVID-19 fear, and also negative appearance scale and self-esteem, well, although significant associations were not detected, but similarly lower COVID-19 fear among the street cleaners, and also similarly lower appearance fear of the garbage workers. So, but this could also lead to depression because of the resilience, which might need a further study. So the final parts will be about the correlation of these psychological distress. So the first is about the correlation between variables. So if you could take a look at it, the GAD7 is anxiety, and the PHQ-9 is depression, and FCV, this is fear of COVID-19. The final one, FNAES, is negative appearance evaluation by community. So apparently anxiety, depression, and PHQ-9, and also negative appearance were correlated with one another, which also support the previous studies. So the final one is about the correlation of psychological distress. So according to, if you take a look at the tables on the left side, in terms of the first table is about GAD, and the second part is PHQ, which means the depression. So about anxiety, fear of COVID-19 scale, and depression, and definitely the significant correlates of the anxiety. And for the latter part, for depression, the fear of negative appearance and also anxiety significant correlates. This is also supported by previous studies and targeting the essential workers working during the COVID-19 pandemic. So I'd like us to quickly go through the conclusion and future prospects. So the first thing is about the high prevalence of psychological distress, which means depression. So this is the huge finding, especially among the few studies conducted among the garbage workers. So this could lead to a greater risk at poor mental well-being. And also the contributing factors for poor mental health was COVID-19 appearance-related fear and evaluation, and anxiety and depression. So this means that the prolonged problem, at the same time, we could expect the possibility of a stigmatization by community. So for future studies, we seek to explore several backgrounds, not only limited to COVID, but also more like in personal backgrounds, such as the socioeconomic situation, job-related stresses, and individual story behind the target population. And finally, physical health outcomes, such as high blood pressure and other physiological consequences. And my apologies for the mismanagement of the time. Well, thank you very much for listening.
Thank you very much, Dr. Sai, for your very interesting presentation. And I'm sorry also for the mix-up in the time management. We now go to the Q&A session. I have one question here from Dr. Neni Sintawardani. Can you explain more the difference between depression and ignorance that could be happen during your study?
Excuse me, I couldn't catch the latter part. Could you repeat the question again? Because of the connection.
Can you explain more the difference between depression and ignorance that could happen?
Ignorance that could be happened. Ignorance means, could you be more specific? Thank you very much for the question.
Dr. Sintawardani, can you?
Thank you.
Yeah,
Akira-san, that's sometimes in the field we cannot really, or people cannot really understand about their depression. Instead of maybe they are more ignorant person. So how could we really make it sure that it's depression? That's all. Thank you.
Okay. Ignorance. You mean ignorance by the community members? Okay, thank you very much, Dr. Ibu Neni. As well, previous studies suggested that the ignorance, which means a kind of physical avoidance, And this could be a contributing factor for the psychological distress, for example, anxiety and depression. However, this time I couldn't, I wasn't able to examine the prevalence of stigmatization by community members. Through the qualitative studies, it was surprising that some of the workers mentioned that they received the actual avoidance and from the community members, including family members. But at the same time, they mentioned that they don't care. But according to the findings I've shared with the audience, show that clearly, well, even though they try to convince themselves that ignorance and stigmatization is a not issue, but this could secretly affect their mental health. And that is my explanation. I hope I answered your question. Thank you very much for the question, Dr. Ibanin.
Okay, thank you, Dr. Tai. Unfortunately, we only have time for one question. So thank you again for your very nice presentation. Okay. And now we will go to the second presentation. We will have a special joint presentation by Dr. Neni Sintawardani and Dr. Ken Ushijima, entitled Sanicam, an event to stimulate young people's interest and curiosity about water and sanitation. I would like to remind you that the time for presentation is 15 minutes. And probably during your presentation, there will be a call for prayer. So I would like you to have a little break and then continue after the adhan, if that's possible. Okay. Okay. Dr. Ushijima and Dr. Sintawardani, the time is yours.
Thank you. Yeah, I think Dr. Ushijima will operating from Hokkaido, please. Can you share the slide? Ada. Okay. Okay. Okay, thank you. So here our presentation will be a tandem between me, Sintawardani, and Dr. Ushijima from Hokkaido University. And our title is about Sanicam. This is an event to stimulate young people's interest and curiosity about water and sanitation. Next slide, please. So in the introduction, this is we talk about the frame of research collaboration between LIPI, or the nowadays BRIN, with the Research Institute for Humanity and Nature, or RIN, Kyoto, Japan, from 2017 to 2022. This is we talk about the community actors for agent of changes. Mostly we have found, or in the literature, mostly adults as decision makers and the responsible persons, especially for dealing with sanitation infrastructure and management. So in our study, is the case more about material flow and sanitation, especially about waste, feces, and urine. So for the implemented technology, actually we face the challenge. Is it acceptable or difficult for users or the community to accept such kind of implemented technology? Normally, the rejection is due to the customs, behavior, culture, religion or belief, and technical difficulties. And when the community could accept and implement the technology, it's because it simply helps them a lot. All this technology has an added value results. So now why young people can play an important role on technology acceptance. So we can see the youth and the children, it's more flexible to accept and adapt to something new. And they use, normally now, they use information very vast through social media or internet. So that's why their acceptance of new environmental friendly technology will further increase the chances of acceptance by older people or parents. So the role of young people as agents of change to improve sanitation and the environment is a concern in this study. Next, please. So now we talk about SaniCamp. Actually, this is a sanitation camp that we planned. We have a camp, a real camp in a special place with the youth from many countries. But because of the COVID-19, we cannot realizing that. So in the SaniCamp, it is the participant is students from a senior high school in Kiara Condong, Bandung, Indonesia. And the second group is students from a senior high school in Furano, Hokkaido, Japan. And the third group is young people. They're member from an NGO in Lusaka, Zambia. But this will not be reported. And the event was held online only for a half day due to the significant time difference between the Indonesian and Indonesia and Japan's participants and participants from Zambia. So that was in January 2020. The event began with two speakers who gave material on sustainable sanitation and value chains, and the other topics about introduction to several new and environmentally friendly sanitation technologies. And then each group of participants presented their results of their environmental observation in turn and ended with a full discussion among the participant itself. Next, please. So from the Indonesian participant, they were the student from state senior high school. 25 young people were randomly selected from the second grade students. They belong not to the special extracurricular group, just randomly selected. And they were not given any instruction on sanitation. But a week before the event, they formed 5 subgroups and observed around their homes about issues of clean water, waste, and garbage freely. And their observation were compiled for the presentation materials at SaniCamp. Next, please. Yeah, that's some example from the result of each subgroup. We can see actually they have differently thinkings about sanitation, water, and so on. Very interesting. And then next, please. And then there's the results in some photos. For them, many of the participants a bit shocked to see their own environmental conditions from temporary garbage, from the sewerage or river water, and the clean water in some households. One thing's about the voluntary community movement for the sake of the community to clean their community. So this is some findings, very interesting. And the next for Dr. Ushijima, please.
Thank you. My name is Ken Ushijima from Japan. So I will introduce the Japanese participants first. From Japan, Furano High School students who belong Science Club was attended. They reported the results of their activities about the community-based managed water supply system. So Furano High School is a public high school, Hokkaido. The students are coming from Furano City and the surrounding cities. This school has about 500 students and participants. Students are from Science Club. the presentation contents were based on their bit long time their activities. The science club in Furano High School have been provided from 2018. They did the water quality analysis and GIS map of water supply network they make, and also they held annual reporting event for local community-based managed water supply system. So this is the picture of their research activity, and also this is the annual reporting event. Then they reported their experiences like this. Okay, I hope the movie is available. I want to show some part of the study camp.
Aku masuk udah
as
langsung
Ibu Neni
yang
mentioned,
tadi juga loh.
yes. First, we had some specialist presentation from professor from Hokkaido. And yes, Dr. Neni also presented for the high school students. Yes, so because we use different languages, so presenter used English and their national languages. And then after that, students presented. For example, this is a presentation by Japanese students. I have translated to the English. And next is from Zambia. Then the next is the students from Indonesia. As you can see, some languages are combined in the presentation. Then after that, the students discussed on the Zoom like this. Okay, so the whole movie of Sunny Camp is available on the YouTube. So if you are interested in, please search Sunny Camp on the YouTube. Okay, then after the Sunny Camp, we asked the participants the comments after the Sunny Camp. So this is the movie of the comments by students. Okay. All the participants enjoyed the sunny camp, and also many of them mentioned that they want to join again if they have chance. Then some media in Japan reported this activity in the newspaper, for example. Okay, let me proceed to the conclusion. So we succeeded to set online workshop Sunny Camp as a chance of international communication for young people. And simple but important result is no technical barriers were observed, and also the students from all three countries could communicate each other without any barriers via online. And media showed interest to this kind of activities in Japan, and media exposure chance. They see the newspaper, and that kind of chance encouraged participants to the next activities. So now we are considering that continuous communication is expected, and also we expect some kind of real collaborative activities as the next step. Okay, that's all our presentation. Thank you very much.
Thank you, Dr. Ushijima, and also Dr. Neni Sintawardeni for the very nice presentation and also very nice activity. Now we would like to invite the audience for a question. Or I would like to ask one question to both of you. You say that the youngsters are the agent of change in sanitation. But the decision to, for instance, buy soap or making septic tank, it's on the parents. So how can this activity will bridge this gap and make them truly agent of change?
Thank you. Can I first, Ken-san? Okay. Why we choose the youth? Actually, because the adults normally it is but hardly or not easy to change their minds about something. But when this is their own children saying something, normally that will influencing stronger to them. That's it is my opinion. Ken-san, please.
Yes, I agree with your idea. So, how to say, the adult is the effect from the children is much bigger than we think. So, just talking in the home is very easy to change the mindset of the adult, I think. Thanks.
Okay, thank you again, Dr. Sintawardeni, Dr. Ushijima for the presentation and answering my question. So this is the end of our first oral session. Thank you very much for all the presenters. And for the discussion, I would like to return the session to MC. Thank you very much.
Okay, thank you very much for leading the first oral session, Dr. Widyarani, and to all speakers, Dr. Sai, Dr. Ushijima, and Dr. Sintawardeni. Thank you very much for your presentation. We are truly enlightened by your session. And next, we're moving on to the next oral session. So for this session, we kindly invite Ms. Radentina Rosmawina as moderator, and also for all the speakers in this session. So I remind you, for any question, please type or write down in the chat box during the presentation, or simply click the raise hand button, because we will have Q&A right after each oral session. Please write your name and for whom the question is. So yeah, without waiting any further, Ms. Gina, the time is yours. Thank you.
Okay, thank you, Dr. Nur Amalina. Good afternoon, ladies and gentlemen. My name is Tina Rosmalina. I will be a chair for this session. In this session, we will have one oral speakers from BRIN Niaga Medica. Before start, I'd like to remind that the presentation are given 25 minutes for presentation and 5 minutes for Q&A session. If you have any question, please write down your question in English in the chat box during presentation, because we will have Q&A right at the presentation session, or simply click raise hand button and I will give you the permission. Now I'd like to invite Ms. Nelfriani as Account Sales Manager SF1 from BRIN Niaga Medica, who will be talk about protecting the environment with reliable instrument Agilent GC, GCM, SMS. Mrs. Nelfri, are you here?
Yes, hi. Hello, Tina. How are you?
I'm fine. Long time no see, Ms. Nelfri. Okay, Ms. Nelfri, the time is yours.
Thank you so much. I will share my screen. Share my presentation. Sorry, did you see my screen?
Yes.
Okay, now you're seeing my presentation, right?
Okay.
Okay, so I will start. So everyone, good afternoon, ladies and gentlemen. My name is Nelfriani. I'm from PT BRIN Niaga Medica. Thank you to GreenVC 2022 committee to organize this event and the opportunity given to us. Today, I will be sharing about how we can protecting the environmental with reliable instruments focused on GC, GCMS, or GC-MS-MS analysis. This is our company profile. So our vision and mission is being a distributor that trustworthy and reliable by the customer, to continue to provide high quality instruments and excellent after sales support in order to achieve customer satisfaction and profitable business. BNM has awarded the certification of ISO 9001-2015 of quality management system, and the other ISO for our group, healthcare solution group. And then this is our principle and products. From Agilent, we have liquid and gas chromatography, and we also have Gerstel for automated sample preparation, PIC for gas generator, Frontier Labs for pyrolyzer, and also we have Watson and GBA as value-added reseller from Agilent to fulfill the customized configuration and guarantee application. Talking about how to protect the environment, we all can partake in. As an individual, we can bike to work or commute with public transportation, doing the reuse or reduce and recycle. And then we also can plant trees and shop wisely, and so on and so forth. But in order to making life, we also doing activities that produce waste. Is it personal or industrial waste? We need to manage and minimize the impact and organization personal activities have on the on environment, either to ensure compliance with laws and regulations or to mitigate risk of harmful effects on the natural environmental and protect the health of human beings. As an institution, we can take part in monitoring contaminants in environment metrics. Environmental monitoring is a tool to assess environmental condition and trends, to support the policy development and its implementation, and develop information for reporting to the national policymakers, international forums like us today, and the public. The monitoring of urban air pollution have important impact to human health risk. And also if the solid and hazardous waste monitoring is weak or industrial emission are also not well monitored, will be reducing the effectiveness of policy instruments such as emissions charge and fines. Environmental monitoring can be like air monitoring, water monitoring, soil monitoring, waste monitoring, and also biodiversity monitoring. The analysis of soil contaminants and determinations of their effect on human health and crop growth are critical important areas of environmental monitoring. The scope of soil monitoring can range from analysis of trace toxic metals to organic contaminants, including polycyclic aromatic hydrocarbons, or we know as PAH, petroleum hydrocarbon, and a wide variety of pesticides and herbicides must also be tested for. And the methods used are required to be efficient, cost-effective, and robust to ensure regulatory compliance. And also, everyone here, of course, committed to ensuring the quality of our water supply, as well as understanding that this is essential resource is but limited and in jeopardy. Clean water sources are running dry, chemicals, contaminants threatens existing supplies, and emerging hazards are being recognized every year. The scope of water monitoring such as VOC, SVOC, pesticide residue, microplastics, and phthalates. And also the air monitoring. Effective air monitoring is critical in a variety of application and environmental, whether for greenhouse gas monitoring or for maintaining air supply quality in our building, in our work environmental, and detecting, measuring a wide range of airborne contaminants is vital and ongoing challenge. There are numerous health hazards associated with toxic air contaminants, as well as significant monitoring difficulties due to the particle size, scarcity, and the matrix complexity. In addition, regulations are becoming increasingly stringent, and the list of harmful substances that must be tested is growing. It is important that analysts can quickly and easily gather a uniform sample and execute multiple testing methods, and requiring the most accurate, sensitive analysis solution with very low detection limit. As part of the monitoring programs, environmental regulatory agencies or related institutions require reporting of the types and concentration of organic and inorganic compounds discharged into the air, water, or soil. Today, challenges have never been greater, whether analyzing contaminants in wastewater, in surface water, or purity of drinking water, measuring indoor air quality, outdoor air quality, responding to the natural or man-made disaster, or identifying emerging contaminants. The environmental analysis must be done more reliable, more efficiently, with the higher quality result than ever before. So here we introduce the gas chromatography. Actually, gas chromatography mass spectrometer, or GC, GCMS, MS, is widely regarded as the analytical techniques of choice for the analysis of semi-volatile organic compounds, volatile organic compounds like microplastics, chemicals, residue in water, wastewater, soil, and air. And here you see the Agilent portfolio range from GCMS single quad for qualification and quantifications analysis. And also we have GCMS triple quad or GC-MSMS for targeted, very trace level targeted analysis, and also GC-MS-TOF for unknown analysis. You see in the pictures from left to right, performance analysis is getting better, and it is, of course, equivalent to the higher price of instrument. This slide shows the flow of GC-MS. Separation compounds happen in GC and then transfer to the ion source to ionize the compounds, the substance, and then enter the quadrupole for ion selection or filter by mass charge, and then detects in detector. So single quad GC-MS usually used to identify and quantify low-level analytes and unknown volatile compounds in various metrics such as solid, liquids, and gases. For GC-MS-MS is same, but there is an ion selection in we call it triple quadrupole because it has a quadrupole, the third quadrupole before enter the detector. So GC-MS-MS analysis to quantifying trace level analytes, very trace level analytes. Extraction of ions in ion source could be like EI, PCI, or NCI, depends on the analytes that we want to analyze. Ion source to ionize the molecules, but we have to take note that most molecules are not ionized here. There are many neutral then ions or matrix ions than analytes ions that we want. The cooler the surface is, the more contaminant. To avoid contamination problem and ensure robust performance operations, Agilent has technology such as inert source that could be operating up to 350 degrees. This is we call it like hot system. And then Agilent has also gold-plated quartz, so it could be heated up to 200 degrees Celsius. So if you want to clean the quadrupole, you just heat it the quadrupole. Agilent built on the proven robust of MSD hot quadrupole. And then after we produce the ions, analyze ion focus into the first quadrupole to isolate of the precursor ions. Example, like we targeted the ion 210 in the first quadrupole, so we only filter the 210 ions separated from the matrix ions or neutral ions. After enter the quadrupole, first quadrupole, and then the analytes comes to the second quadrupole, or we call it coalition cell. Agilent has technology that called helium quenching. Here in GC-MS, we use helium as a carrier gas. In the ion source, during the ionizations, the helium will produce, it calls metastable helium that could be a noise in detections. To reduce the metastable helium, we have a helium quenching by adding small amount of helium, and then it will be neutral. The benefit is to get more sensitive instrument result by reduced neutral noise, means that we have low limit detection. After that, the sample come to the mass filtering of the product ion in the second quadrupole before detections. Further bonus when we are using sensitive technology, sensitive instruments, that the entire method requires very small samples, means we require very small solvent. And since many solvents are toxic, hazardous, and harmful to the environmental, the reductions in the amount used would be particularly meaningful and fitting in order to reach environmentally sustainable solution for chemical analysis. So this is an update from GCMS and GCMS analysis. Agilent discovered the possibility of sustainability. When Agilent is committed to improve sustainability in our operations and also in your operation, our customer operations. Agilent have partnered with My Green Lab to have the instrument independently audited for their accountability, consistency, and transparency level. And the helium crisis is affecting several countries across the world, including Indonesia. Helium in efficient production process is making the supply chain unreliable and very expensive to get. Comparatively, we know that hydrogen is a low-cost, easy-to-produce gas that is best for GCMS or GCMS alternative to helium. But despite this, hydrogen does come with its own set of analytical limitation as well. So Agilent sees this issue and developed a technology called hydroinert. Hydroinert is the ion source in GCMS and GCMS. So the example of analytical challenges of using hydrogen due to the reactivity. On the top, an example of nitrobenzene, an important compound in EPA 8270 list, and one of the most problematic compounds when it comes to hydrogenation of the source reaction. Due to the in-source reactivity, we converted first to the aniline. After that, we analyzed with the EPA method 8270. You see the result, the peak is tailing, the spectral fidelity is not really good here. However, the hydroinert source advanced the improvement noticeably further and allows the address to even more challenging compounds like nitrobenzenes. So the design of the hydroinert to help lab confident migrate to hydrogen without compromising on an analytical performance. In the hydroinert source, the set of GCMS source components and the flow path is unchanged, similar with the GCMS, the current GCMS. The difference is the material that helps with the hydrogenation of analytes. And it's also available in 5977 inert plus and also GCMS 7000 triple quad. So here's the comparison of the excellent spectral fidelity using the new hydroinert source. Both these are using the 9mm lens. We can see here that there is a tremendous improvement in the spectral fidelity with hydrogen source, hydroinert. And also similar with the EPA method 7270, you see here in the bottom, the data with the hydroinert source are showing an improvement in peak shapes. Agilent also will have the application note to showcasing the proof performance of SVOC, VOC analysis with the hydroinert source. And this is some of application in soil monitoring, such as MTBE residue in water and soil using GCFID, determination of volatile aromatic compounds in soil by using manual SPME and GCMS for detection, and for screening techniques of dioxins in environmental sample, we can also using GCMS. And in air monitoring, you see in the screen, air pollution can occur in both outdoor and indoor setting and affect the health of us as a human. High emission of health damaging pollutants such as particulate, carbon monoxide are now increased risk of disease like cancer, respiratory problems, tuberculosis, or even cataracts. And I read in the WHO website says that In 2016, household air pollution was responsible for 3.8 million deaths. It means like 7.7% of global mortality. The government of Indonesia has included air quality and climate change in the National Midterm Plan as part of the National Priority Development Agenda, and also Health Standard and Regulation number 1077/2011 on guidelines for air safety in the household. This show that Indonesia government is very serious to take this analysis in terms of air safety. We can see here some parameters such as SO2, NO2, CO2, CO, VOC are regulated. It can be analyzed using GCMS or GCMS-MS. And some application in air monitoring using Agilent GCMS with sample introduction, thermal desorption from marks, like air indoors or inside vehicle cabins pollutants, workplace monitoring, or investigating biological exposure, research in air contaminants, and also the material emissions. You see in the pictures like breath analysis, right? It could be done to analyze the biomarker discovery, non-invasion diagnostic, occupational hygiene, and exposure testing. And also GCMS can be done to analyze PFAS, of course, the volatile PFAS, complementary to the HPLC methods. The water analysis. So you saw in the screen that we have, I showing some of the application, two of application that currently hype, such as microplastic particles that defines the dimension of the particles between 1 micrometer to 1,000 micrometer, and consisting mainly of synthetic polymers that observe nearly everywhere in environment. Through the systematic occurrence of microplastics in environmental sample has not been sufficient investigated, it is necessary to fully understand their relevant source and entry pathway into our food and environmental ecosystems to initiate the sustainable prevention strategies. So this microplastic persistence increase in the environmental because it's a fragmentation of microplastic and remain for uncertain period of very long time. So the risk, and also now the risk is unclear and the subjects are controversial. The result, it increased interesting in determining microplastics and in environmental sample, such as soil, water, air, and organic matters. We can use GCMS or LCMS method, but because it's very challenging because of the very high molecular weights and poor solubility in most solvent of the microplastic itself. So one approach to analyze this microplastic is using TD-GCMS. It's robust, and you just need to solve the polymer without any additional preparation. We can use the TD-GCMS. And also with TD-GCMS, you can detect all particle size in the samples as long as the limit detections is reached. Last but not least, we have a gas generator, including hydrogen generator from Peak Scientific. So gas generator is convenience because it's like gas on demand. You don't need cylinders to change, or you don't need to maintain your supply stocks. And also it consistency because the quality and the supplies is consistent. There is no impurities or there is no reason to running out of gas. And also from economic scales, it's eliminate ongoing cost of cylinders, but maybe the investment is a bit higher compared to the cylinders. And the the best thing is it's safety because it's no pressure cylinders in your lab, and also green because no repeated gas deliveries, energy efficiency. So it reduces our carbon footprint.
Sorry, Ms. Nelvi, 1 minute left.
Yes, this is my last slide, and we believe that hydrogen is a safer option for you, for your college, for your workplace and environmental. So thank you very much. You can connect with us. This is our WhatsApp care and email and website. Thank you very much.
Okay, thank you, Ms. Nelvi, for the nice presentation. So now we will turn to Q&A session. And I find the question in the chat box come from, sorry, host.
I saw someone raise hand.
Okay, the question come in the chat box. The question come from Dr. Diana. Dr. Diana asked, how about the limit detection for volatile organic compound in the air sample analysis using GCMSMS?
Okay.
Maybe you will answer direct.
It's very varied. Depends on the components itself. But as long as we provide this instrument to our customer, we believe we can comply to our SNI, Standard National Indonesia. And if you also want to use the GCMS, we can add on the thermal desorption itself to reconcentrate or to concentrate the samples before it's analyzed in GCMS.
Okay.
There's a PPB level, PPT level. Yeah, it's very
PPB or PPT, yeah.
It depends on the compound.
Yeah, okay. So now I will invite Dr. Chandra Risdian to ask. Okay, please.
Thank you, Ms. Tina, and thank you very much for your presentation.
Maybe you can open your camera, Dr. Chandra.
Yeah, sorry. Thank you very much, Ms. Tina and Mrs. Nofrani. Very nice presentation from you. I have two questions. Yeah, the first one is about the hydrogen generator, and how do we produce this hydrogen? Is it from water? And if it is from water, what kind of water? And the second, how about the nitrogen generator? If we want to have the MSMS system, do you also provide the nitrogen generator for this collision shell? Maybe that's all my question. Thank you.
Okay, thank you, Pak Chandra. For the first questions, the first question is how to make the hydrogen from water, right? Yes, it's made from water, electrophoresis method, and then we separate the hydrogen and oxygen. And what kind of water that we use is diamine water. So we will give you the parameter of the water that supposed to be used to the peak generator. And then the second questions is, yes, of course, we provide the nitrogen for LC-MSMS collision cells. Yes.
And this is also from normal area for the nitrogen generator?
Yes, the nitrogen generator is basically we only filter the air in our area. So all we have is a filter that you need to change like 6 months or 1 year as a consumables. Depends on the how you utilize these instruments. Some of customers changing like 6 months, some of them like changing every year.
Okay, nice information, nice answer.
Thank
Very
you,
nice.
Mbak Chandra.
Yes, Novriana.
Okay, thank you. And now we have one participant to ask more. Okay, Miss Ida Munfarida, please.
Sorry, I can't hear you because okay.
Okay, Miss Ida, please. You have unmute your microphone, Miss Ida.
Hello, Miss Tina.
Yeah, okay. Now it's clear. Please.
Okay, I would like to ask about the GCMS tool. We have already GCMS tool in our lab, but in order to analyze the microplastic, you said that it needs a TED GCMS, right?
Yes.
Is it possible to just add TED to our GCMS to analyze? Is it possible to just adding that TAD addition? And how about the cost? We are planning to buy the tools maybe next year if it is possible and it's not expensive. Okay, thank you.
Yes. For the short answer, I will say yes. It's possible to add on the TD in your systems, but again, we need to come to your place and checking all the things to make sure the mounted is suitable. But it's possible to add on the TD only. So TD is upgradable because it's a different instrument. Like it's not part of the GCMS. It's a sample introductions. So it's additional things, yes. And the price, I will contact you directly, Ibu, to talk about the price.
Okay, maybe it's better behind the skin, yeah? Not
Yes.
in Zoom. Okay, maybe the last question is for me, Miss Nelvi. Mostly we use helium for carrier for GCMS, yeah?
Bu Tina, you mute.
Yeah, okay. Mostly we use helium for carrier in GCMS, but now in common, hydrogen in common used for carrier in GCFID. How about the hydrogen as a carrier in GCMS? Is it possible, or how about the safety? Because it is seldom to use hydrogen for carrier in GCMS.
Okay, hydrogen in GCMS. Just now, actually, I am mainly focused on hydrogen as a carrier gas in GCMS. Yes, it's possible, but as I mentioned before, that the issue is you will get like not nice shape of peak, and but with the hydroinert is a new source from Agilent, new ion source from Agilent that it makes possible for you to use the hydrogen as a carrier gas with the very nice peak result.
In GCMS?
In GCMS. And
how about the safety?
How about the safety? The safety itself, we have like a hydrogen leak tester that if it's in Agilent system, if it's like more than 0.5 ppm level or 0.4 ppm level leak of the hydrogen, the system will be shut down automatically.
Oh, okay. So this is the system will automatically reduce, yeah?
Yes.
Okay, thank you.
Thank you.
Anyone? Maybe the session is finished, yeah? Okay. Oh, udah. Okay, I think this session is finished, yeah. So this is the end of the session. Thank you very much for Ms. Nelfree. I apologize for any inconvenience. I will give next session back to MC. Thank you, Ms. Nelfree.
Thank you. Thank you, everyone. Have a
See you
nice
then.
day.
Yeah.
Okay, thank you very much for Ms. Tina, who already lead us the second oral session, and thank you to Ms. Elfriani from PT BRK Niaga Medica for your interesting presentation. To all ladies and gentlemen, before continuing to the next session, we will have a break for 1 hour. But before that, we'll have a quiz, and the prize will be given to 3%. And then the quiz will be performed through Kahoot.it platform. So for those who are not familiar with Kahoot platform, please pay attention to the guidance on screen. First, make sure that you have a stable internet connection. And for this quiz, you need a device other than your laptop that you already use for this Zoom platform. So for example, you can use your handphone and then type kahoot.it on your phone, enter the PIN game, and then tap your real name. So remember, real name, so we can easily contact you if you become the winner. Please pay attention to the question you shared on the Zoom screen. You can choose the answer from your other devices by matching the color. For example, if you choose blue as an answer, then you may choose the blue one on your other devices. For example, if you choose blue, then you should also choose blue on your phone. We will wait all the participants to join the quiz to enter the Kahoot. So we will wait for 1 minute.
Pinnya berapa pin?
So I will count down until the quiz is started. 5, 4, 3, 2, 1. Okay, let's start. Okay, we already have 3 winners here. And the first winner here, who is Kamune, 3 times. And the second winner is Rina010. And the third winner is RZKYPRTM Adi. Okay, congratulations for all the winners today. Okay, for each winner, please contact the organizing committee to confirm the prize. Okay. So the first quiz is over. So for those who haven't won yet, we will have another quiz tomorrow. So make sure that you attend the symposium until tomorrow. Now we will have a break for 40 minutes. To all participants, please kindly stay on the Zoom room and we will back shortly. Okay, good afternoon and please enjoy your break. Thank you very much.
Indonesia is the most beautiful land in the universe. The land where we were born, the nation where we grew up. So many colors that live together in peace. With a million timeless treasures, with an abundance of natural wealth, Indonesia is not just wonderful. Indonesia is a wonderland.
Kota baru gunungnya bamai jauh, bamana ku di Salangkarang, bamana ku di Salangkarang. Batamu lawanlah Adinda iman di dadara, Samalayang iman di dadara, Samalayang. Sayang si patokaan, makai go gorokan. Sayang si patokaan, makai go gorokan. Sayang sajojo, you madam komi sabapare samuna keke, samuna keke. Soleram, anak yang manis, janganlah dicium, sayang kalau dicium merah pipinya. Kampungan jauh di Batu, Kunwangsan sebaku liliang, takkan ajo kawan-kawan nalamu, sangke basuh yang surya.
Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born. Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born. Indonesia is the most beautiful land in the universe. The land where we were born, the nation where we grew up. So many colors that live together in peace. With a million timeless treasures, with an abundance of natural wealth. Indonesia is not just wonderful. Indonesia is a wonderland.
Kota baru gunungnya berbeda, berbeda bagaimana pur di Samangkara, bagaimana pur di Samangkara. Batamu lawanlah Adinda, Adinda iman di dadara, sama layang iman di dadara, sama layang. Sayang sayang si patokaan matego tego gorokan sayang. Sayang sayang si patokaan matego tego gorokan sayang. Sajojo sajojo yumanam komi sabapare samuna muna muna keke samuna muna muna keke. Soleram, 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 anak yang manis, janganlah dicium, sayang kalau dicium, merah pipinya. Kampuanan jauh di Mato, Gunung San sebaku liliang, takkan aja kawan-kawan lamo, sangke basuh yang suriang.
Ever since its inception over 70 years ago, Horiba has continued to meet the challenges of a new and evolving society by manufacturing analytical and measurement instruments. Analytical and measurement technologies are essential in many different fields. The transition to a carbon-neutral society has created a variety of measurement needs with respect to researching and commercializing new energy sources, such as hydrogen and the utilization of carbon dioxide. Analytics and measurements are essential for both technological innovations in the mobility sector, such as electric and connected vehicles, and for protecting the global environment, including air and water quality. We want to convey to the world the joy that understanding through measuring and analysis brings. Horiba's technologies are shining a bright light on a future yet to be born.
Welcome back, ladies and gentlemen. Next, we will have parallel oral session. As participant, you can choose any room based on your interest. We have different topics for each room. We will have room A, B, C, and D listed on the schedule. To all the honorary oral speakers, you can join the breakout room from now, and please make sure that you are in the right room by checking the schedule. And to the honorary participants, you can choose and join the breakout room based on your interests. For your information, all the parallel oral session will start at 1 p.m. until 5 p.m. The organizing committee will choose 2 best presenters and announce the winners tomorrow at the closing session. Okay, next, I would like to ask everyone to just join our breakout rooms after this. So I am Nur Akmali Hidayati signing out. Good afternoon and have a good discussion. Thank you very much.
Test. All the remaining participants in the main room, you can choose the breakout rooms by yourselves based your interest. Each title of each title can you can found in each room title. Thank you. Otherwise, we will assign you randomly to the room. Thank you. Test. Tes tes. Belum, Bu. The remaining participants and presenters who still in the main room, you can choose the breakout room where your interests. Otherwise, we will assign you to the room randomly.